I'm here with Alan Timm, who will be giving the first talk. Alan, when you are ready.
All right. Good morning, everyone. Let's go and get situated and share the screen. Almost there. All right, let's see how that looks. Okay, try something new. Recording. All right, so last month, after going on and on about LangChain and generative AGI, you think, oh, he's just around the corner, he's going to crack intelligence, and he'll tell us all about it next month. Well, as is the case oftentimes in my life, something shiny comes along and I change direction a little bit. So I was getting my hands dirty with LangChain, figuring out how to do directed cognition. And then I looked back at the ChatGPT mobile app and said, hey, wouldn't it be cool if I had my own version of the ChatGPT mobile app that connected to my personal generative AI, and wouldn't that be awesome? And then I remembered a few years ago that there was this development platform called Flutter, write once, run anywhere, what Java promised but then failed at. I said, what's an excuse to kind of get back into it? So I'm like, oh, it'll just take me a weekend. I'll get in there and I'll write a quick app and we'll be good to go. So that's how we landed on Flutter this month. So I started working through the process, and I'm gonna I'll share with you everything that kind of led up to it in case anyone else is interested. And then at some point, my attention shifted again. I'm not ADHD, I like shiny things. And on campus in my job, I'm in operations for beach building services. We have a platform to manage our work order tickets. And we have been waiting for the vendor to produce a mobile app for 5 years. And it's always just around the corner. And the weekend after I started working on my personal ChatGPT app, I got frustrated, or a light bulb went off in my head. And I said, hey, wait a minute, writing apps isn't that hard. Why don't I get permission to burn some amount of hours for feasibility on writing our own mobile app with our own features and our own business logic, just to see A, if it's possible, and B, what the amount of effort it would be to get it done. And 20 hours of work and personal time later, because it was so much fun to do, we've proven not only can we do it cost effectively, we'll own the business logic, it's not that hard to maintain. So we'll probably, on our work side, we'll authorize funding for the data connector for our work order ticket system, and then probably 80 to 120 hours, we'll have a fully fledged mobile app for our technicians that works exactly the way that they want to, written in Flutter. We'll have an Android app available. There will be a web app. The possibility exists for us to generate an iOS app, because all of our techs, we use iPhones. Those are our main work phones. And so far, aside from taking ownership of it from this point forward, there's been zero downside. So that is why this month's talk is Flutter. Why Flutter? So just to quickly bebop around a little bit, this is a screenshot of the mobile time card portion of our app that we put together in like 10 hours, and 3/4 of that was figuring out how to do it the first time. I'm not claiming this is the prettiest implementation, but luckily I have access to a UI UX designer that I'm going to hand the screenshot to and say, hey, make this your own. I can literally reproduce any UI that you can dream up. But yeah, so far so good. Getting back to what is Flutter? As I mentioned, Flutter is a Google-backed development platform. It, in turn, is based on the Dart programming language. And the promise is of Flutter, apps for any screen. Most of the widgets and the things that it does lends itself well to a material type style. And I'm not a web developer. I never was. I never probably will be. But looking at how you describe the UI using Flutter and Dart, it looks a lot like CSS on CSS had a stepchild with C# or some other type language. And like once you get the gist of it, it's pretty easy to iterate quickly on it. There are a lot of awesome things built into the Flutter ecosystem. I'm using it. It will partner up really well with Android Studio if you want to focus on Android apps. Wherever you install it determines which type of applications you'll be able to generate. So on this install on a Windows computer, it'll generate a Windows executable, it'll generate a web app, and if you have Android Studio installed, it will generate an Android APK, an Android application as well. On Linux, it generates a Linux app, and if on a Mac, you'll be able to generate code for an iOS app. So pretty darn cool. In addition, coding in Flutter and Dart on VS Code is a dream. It's a fully featured IDE with autocomplete and predictive and great documentation, and right-click brings you into the source code for anything anything you're trying to use. It also supports something called hot reload. So anyone who's written any kind of code, the normal cycle is you write the code, then you compile it, then you plop it where you want to run it, and then you run it, and then you see if you get any errors, right? In Flutter and Dart, it supports something called hot reload. So as soon as you hit save from, in your debugging development environment, as soon as you hit save, it attempts to compile the code. If it's able to compile it, it hot reloads the code into your destination for web or Android, or I'm assuming iOS, and also Windows and Linux. So it's one of those things like, okay, well, it's awesome because you can iterate really quickly. And when we go through this talk, I'm not going to sit here and claim that I'm a Flutter developer now. And I was trying to figure out, like, well, why are we talking about this? I wanted to give you a general familiarity with the platform and what its capabilities are. The sky's the limit, something to keep in the back of your head. If you ever need to write a web app or an Android app, this would be, I think, a great option for you. It's supported by Google. I know sometimes Google will drop projects at the drop of a hat, but this is pretty well established. And just from working with it over the past couple of weeks, it is a joy to work with overall. From autocomplete and the documentation, the way the IDE works with it makes it very easy to iterate and learn and figure out. And the third piece of this point is there are thousands, tens of thousands of hours of YouTube videos describing every aspect of the language, how to use it, the features. So it's very easy to immerse yourself quickly to get the hang of the language, which leads to the third piece right here. Generative AI has changed everything from a development perspective. It's one of those things where you hear about it and then you kind of give it a go and you're like, wow, this is cool. If you're anything like me before this point, if I was going into a new language, I'd spend an hour or two on YouTube looking for the hello world, to get your bearings about how everything fits together. And then from that point forward, what wasn't covered in the IDE would be a Google search for Stack Overflow to figure it out. So I want to make this text bold in this widget. How do you do that? hit Google. Flutter told, if your Google flu is strong and you hit the right keywords, you'll find it relatively quickly. And that's how iteration happened. And I was a Google flu master, so I felt pretty quick at picking this stuff up. Generative AI has changed the whole game. Whether you have set up a free account at chat.openai.com for free access to ChatGPT 3.5 Turbo, or you pay the $20 a month for access to GPT-4. ChatGPT 3.5 is smarter for development than anything that you could run locally. And I've tried a couple of different local models, and whatever their magic is, personally, I think they're using this tier of experts that their coding expert is probably in the 20 to 30 billion parameter range, but it's never been confirmed. And then if you want access to a veteran programmer in any language situation you want, GPT-4 has got your back. So I'll bounce back and forth between the two of those. Occasionally I'll bounce some queries off of like Mistral 7B just to see the personal ones, the ones you run locally, hallucinate a lot more. They're smaller and not as focused. They don't have the magic that ChatGPT does from a coding perspective. And on top of that, there's always GitHub Copilot. So $10 a month. I'm sorry I didn't look up beforehand to see what the back end is for that. I would imagine they transitioned it over to ChatGPT because of their stake in and Microsoft's stake in OpenAI and the fact that Microsoft bought GitHub, but I'm not sure about that. I signed up for a trial, and when you turn it on, you have access to a chat window, and then it looks at your code base as you're writing, and if it sees a pattern, it'll suggest a code completion. And it went from a gimmick to a time saver in like 1 second flat. It's not always right. It does hallucinate a little bit, but between it seeing the pattern of what you're attempting to do, to autocomplete a piece of the form, you can copy and paste, you can select and copy pieces of code and paste it into GitHub Copilot chat and ask it a question. And I'm sorry, you'll select it, and then in chat you'll ask some question about the code, and it will respond at about the same level of expertise as 3.5 Turbo.
You can also put in the comments, right, what you want.
And yes,
that's my
and
thing to do.
and that's the third thing, is that to give it a hint of what you're looking for, you can type in a comment, say, make this text bold 20-point font, white, and then a second later, it'll suggest an autocomplete to do exactly that. Now, from where I'm personally coming from, I'm a code tradesman. I dabble, I get as deep as I can get the job done. I'm not a subject matter expert in any particular language, but when I go in, I immerse myself as much as possible. I'm sure many of you are the same way. So if you have an understanding of the fundamentals of development, meaning you kind of get how code works together, between ChatGPT and Copilot, it'll easily make you 10 times more productive. Possibly even more. This isn't an exaggeration. Just adding up the time from using these new tools, from doing a search, figuring out the keywords, figuring out how to apply it. It's like having a veteran programmer sitting right behind you with infinite patience, and it'll steer you the right direction the right way. To give you a more concrete version of that, this mobile app that Ben and I are working on, it required me to create and expose a REST API against a local copy of our work order ticket database. I think I back up every day and we do reports with it. Now, I dabbled in C#. I kind of know how to consume REST API. This is not my wheelhouse at all. Here's exactly what I did to create a REST API endpoint for everything necessary to support this user interface. Downloaded and installed Visual Studio with the web components in it. I did a quick Google search just to get my bearings. I'm like, I want to create a REST API. And it's like, oh, go to new project, select this, give it a name, and you've got like a hello world REST API project that doesn't do anything, right? And so the tutorial's like, here's, if you want to expose data, you have to write a class that's a data model. And so I did that. And I ended up copying and pasting the source code into ChatGPT and saying, hey, how would I do X? And it's like, hey, buddy, no problem. All you have to do is A, B, C, D, and here's the new source code. So we were pair programming. And over the course of, I would say several hours, maybe 4 tops between 2 and 4 hours, I created 4 or 5 REST API endpoints, parameterized in the same flavor as the production endpoints will behave when we pay for the licensing. And then the same thing for the UI. 20, 40 times faster than if I had to figure it out on my own, and at least 10 times faster on the UX side. So I think my main goal for this talk is to give you an introduction to the programming environment, share with you everything that allowed me to get my bearings, and to show you how pair programming with these other tools will get you from A to B way faster than the old standard, which was Google search. And yeah, one of the things was, it just stuck in my head, was you guys have all seen the memes like only old people use Facebook and only old people use texting. So as a joke, I put in only old people use Stack Overflow and Google anymore.
We're all
That
old.
hurts.
Yes, I know.
I know, that's the
I thought
challenge.
those were those guys.
And so to kind of, with all this as a background to kick this off, I wrote this outline to kind of give me a cadence and how I wanted to approach it. And then I'm like, well, you know what, ChatGPT, write me a talk outline for a 1-hour talk. Can I get rid of this? Introducing the Flutter application development and including utilization of GitHub Copilot and ChatGPT. No problem, buddy. Here's how we go. And I've got this pasted off to the side. And not replace us yet, but it would be silly of me to not take advantage of this as an extra tool, right? Because last week I have one-on-ones with my boss, awesome boss, great environment, and I wasn't sure how much of this ChatGPT was on his radar as a director of FM operations. And so that morning I'm like, hey, I'm gonna grab a meeting room because I've got some stuff I want to show you on the screen. And I said, I don't mean to overstate it, but I'm probably gonna blow your mind on it. He's like, oh, all right. So my one more thing was just giving them a walkthrough of ChatGPT, some of the projected impacts, everywhere else, letting them know that I don't see any immediate impacts to our operations, but I'll keep an eye out. We're heavily involved in stuff. And he had mentioned that his wife had recently changed jobs. She had a micromanager. The dean of the college was a micromanaging Yahoo, and so she changed jobs. So to kind of give him as you can see, I do it. I use this a lot. What is that? Oh, here we go.
Oh, these are your records.
Yeah. So
Previous
and so to show him, nope, that wasn't it. Oh yeah, no, this is part of the demonstration.
Is this what you're in right now on the web? Is that the free ChatGPT?
Yeah.
The web portal.
Yeah. So the ChatGPT, they've got a paid version and a free version. I tend to try the free version first, and it's been amazing. So to kind of start the conversation up, I asked ChatGPT to write a Sparky resignation letter to my college of business dean, who micromanages my every move and has killed the collaboration spirit of my department, right? And his jaw dropped. we'll just quickly go through this. It's perfect.
Your exceptional leadership. Oh, that's a long one.
Yeah.
Is it kind of sarcastic?
Oh, yeah. Very
Condolences
snarky.
to those.
Snarky. Oh, you said snarky.
Yeah.
So it did what you wanted.
And so on campus, we do have an AI steering committee that does meet periodically. It's more politics than application, so I don't have anything to do with that. But it's definitely on the campus's radar from a bunch of different perspectives. And like I keep saying, I don't know what the next 3 years are going to look like. It's not, as this continues to improve, people are finding new applications, new ways to partner with the technology, and everything that we're going to chat about today doesn't even take into account the OpenAI Dev Day talk and all the new features that they just released. So that's going to be my homework for this weekend.
What did they released the new?
Yeah, there's now 4.0 Turbo.
That the letter.
GPTs, yeah, the API now supports text to speech and speech to text
And the visual and the vision stuff too.
Yeah.
Right, you probably got that letter I got this letter from OpenAI.
Yeah.
Saying we have all these things, the 4 Turbo and the larger, the standard length is now 16K. And
They quadrupled the links, yeah.
And it's like really cheap to use the old one, or they lower the prices. It's like crazy.
Yeah, personally, I think they would be silly for not doing this. I would hope that they're using like a GPT 4-bit quantization for portions of it. It's impossible to tell on this side.
Yeah, just a quick question. So let's say you're an Arduino I. Okay, so you're writing some code in C++. How does ChatGPT stare over your shoulder? Are you copying and pasting from the I environment into ChatGPT?
Yeah, so there's a couple different ways that you would approach that. First off, by now, I hope you've moved your Arduino development to Visual Studio Code. But if you haven't, if you're using Arduino IDE with no syntax highlighting and no autocomplete and no right-click help and none of the other fun stuff, what my workflow would be, I would copy and paste the source code into a ChatGPT window.
Okay, then it starts doing stuff, and then when you like it, you put it back in the I to compile it and into the Arduino.
Yeah,
okay, I just wanted to get it right.
And it exactly looks like that. You copy and paste the source code in and hit enter, and then it starts bloviating about it. So you haven't asked a question yet, so you say,
okay,
stop,
I got it.
Stop, and then you ask the question.
And you could continue writing there, but then you would copy and paste it back and down. Okay, that's just what I wanted to do.
Yeah. And regarding the making the input context 4 times the size, aside from the compute cost, right? Because it costs more to support that. Just 2 or 3 months ago, there was a paper published that described a subtle change to rope embeddings that allowed the transformer to take into account the entire context. And you probably ran into this just by using the 16K on before the talk, is that with our current best practices about the encoding and the angles for rope embeddings and stuff that I don't understand, is that for long sequence links, it tended to remember the stuff in the beginning and the stuff in the end, and it tended to ignore the stuff in the middle.
Even with the context, you're saying, even with the context.
Yeah, with the longer context sizes. And I don't remember who did it. I've got the paper on my phone somewhere. Is they figured out that slightly changing one of the parameters in the rope embeddings allowed it to take into account the entire thing. And so I personally believe for the OpenAI thing, I think they've already leveraged that.
So in other words, that's why.
Yeah, so that's that was probably how they were able to suddenly offer reliable, because you can open up to any context length that you want. Kodiyama supports 100K context length,
but how good
it's still
is it?
limited, by.
I see. Oh, in other words, OpenAI wanted to release a good product, so they waited until they had the 16K one that was out, but it suffered from that problem.
I suspect so.
I didn't really get that. Yeah, it seemed to do a decent job at those summaries that we had, even in the middle, but Yeah, I'm sure those weren't that big though. It wasn't even using the whole thing.
Yeah,
Anyway, that's,
where I work, I think they told us that we can't be pasting code into.
yeah, we can't either.
Is that,
Samsung doesn't allow it.
yeah, I mean, is
Oh.
it safe? Or, I mean, you don't know where your code is gonna be going to.
If
you're
you were
writing-
working on some
so-
intellectual property,
Yeah, intellectual
I wouldn't
property.
put any of it. This
Right,
is
so-
for hobby use
We-
right now.
Yeah,
Do
it's-
that, with the whole enterprise thing, so that is a big answer to that. If you're paying for it, there's all sorts of guarantees that they're not using it. You're
Not
safe,
storing
for
it
GitHub, or if
Yeah,
you
pay
use a
for
public
it.
API, if you're doing what you're saying here, pasting it into the, they're scrubbing it, and,
Yeah, they can
You
use
can
that.
find it in your next
says
search.
it in the EULA,
yeah.
but,
Yeah.
so if you're a member of the GPT-4 $20 a month?
Oh, yeah.
So if I sign up for that, then I'm probably, then I have to read it.
Well, that's in between, with the APIs, you're protected,
Oh, APIs are definitely,
and then if you're using Copilot, you're definitely protected.
because you're paying for
That,
that.
the paid one, that, I don't know, it's somewhere.
Oh,
between,
that's
I
a
haven't
little-
looked. I haven't looked at it,
Okay,
I
so
don't know.
Copilot is really secure and the API is secure because you're a paying customer, you have a relationship, they're not gonna
Yeah.
alienate you.
If you trust.
Yeah, if you trust
They
them,
may
exactly.
scrub anyway and just don't use it to avoid lawsuits, or they may decide,
Yeah.
yours too small to sue us anyway, so we're gonna use it.
Yeah, so on the ChatGPT web interface, they have a toggle for chat history and training. And it's a very valid point, because that's one of the reasons, like we were talking about, Tesla and autopilot, is they're sucking all that information in to make it better. Which is great, it's a huge source, and the net good, the net positive is awesome. And that's why they've introduced a new product called ChatGPT Enterprise. So the Samsungs and the, of the world, you pay some amount of money and now you have some guarantees. That's one of the guarantees. I think another one is something about liability, right, for generated code.
Yeah, they've already done that. Microsoft did it, and OpenAI. If you get sued for copyright because of something they suggested, they will cover it. So they indemnify you from that suit.
Oh, well, that's good.
Now again, the free one, who knows?
Because there's a new evidence, I think even legislation that, work that comes out of like an AI system, for instance, like DALL-E, to create, or generative AI is not copyrighted, it's not copyrightable. It is in fact in the public domain. So if you create things using that, it's all public domain, and that's,
So all software has just become the public domain because everybody's using Gen AI.
now I don't know about, at least for images, I don't know if it applies to, but yeah, they're saying that, if you do generative AI, you use generative AI, you create a picture, that picture you cannot copyright that to yourself.
Yeah,
That
there's
is
some,
in the public domain, so someone else can use that picture just as well as you can. And that is one reason why there's a big effort to analyze data and determine if it came from an AI generative engine. Therefore, whoever is looking at that can say, hey, that's public, sorry.
yeah,
This is
the next
active
couple of years
legislation.
in all areas are, and I don't know if it's good or bad that they're trying to do a better job of keeping up.
Yeah.
Oh, the legal
Than they were
system?
before. Yeah.
I mean, I don't know how to feel about it, but it seems like, I guess that, just, to me, just typing a few words and getting this great picture, it's really, can you really copyright that picture because you typed in a few words? Probably, and because of all the other things involved with that.
So before that law, DALL-E had in their terms saying, when we give you that image, you own it and it's your
Yeah,
image.
that's the thing, it changed. It used to
Yeah.
be for like, 2 months, the usual cycle of how things are changing now, that you would own that, if you're copyright, and all the artists were like, kind of like, oh, it's mine, and now they're, now they can't really do that. So it's changing rapidly.
The next couple of years is going to be very exciting.
Well,
Actually, they
it's
already are. but-
Scary to probably a lot of people in the creative industry, too, right?
So, all right, so I'll quickly, oh no, it's a great conversation. I'm gonna quickly blow through some things to keep in the back of your head when you want to use this. The first one is the Flutter SDK. Follow the instructions exactly. They even support install under Chrome OS, which is kind of amazing. It involves downloading and installing a zip file called Flutter. You place that somewhere where you want to be able to access it, and then you add Flutter, wherever it is, Flutter /bin to your path, which differs depending on what operating system you're on. So from that point forward, you have access to the Flutter and the Dart executable.
Is it a command line or something like that?
Underneath it's all CLI stuff.
Okay.
So, and when you follow the install, it'll have you run a couple of commands like Flutter Doctor, and there's some licenses to accept. So just follow the instructions exactly.
You don't have to install it or touch a registry or start menus or anything.
No, and
Portable.
yeah, so in Windows, for example, it's a zip file. So it unarchives to a Flutter folder. I happen to put mine at the root of my user profile in Windows. I did the same thing in Linux, I believe. And then you add the
You have to put the path in your environment, standard old or standard kind of development environment issues.
Yeah, and it'll tell you exactly how to just follow the instructions top to bottom, and you'll be set.
So Dart, you said Dart is the language.
Yeah, so underneath it's Dart. So Dart's run natively on Android. I know on web it transcompiles it to JavaScript.
Oh.
And I can't remember for Windows and Linux and iOS if it transpiles to something else.
Like
Is Flutter just like a wrapper around Dart or something like that? Or
Yeah. So Flutter is built on Dart. So Flutter is the UI portion of the language, and then Dart is the underpinning. And
so Dart has a runtime then, and it runs for each of these OSs like a runtime system.
yeah,
And whether it may be like Java, like byte compile,
Exactly,
or
yeah.
it could be, it probably doesn't compile the native, or it might, I don't know.
yeah, that I'm not sure.
It's
I
kind
just
of
know on
irrelevant. You didn't have to worry about that.
yeah, I just know on web it transcompiles to JavaScript.
And then in Windows, you probably get an exe at the end.
Yeah,
That's awesome.
Wow.
Yep. So if you're not already a fan, go through Visual Studio Code. Even if you're doing Arduino development, the platform IO stuff, and yeah, I wouldn't recommend it if I haven't seen the light. If you wanted a couple of minutes, you can hit me up and I'll show you exactly how I set it up. I can practically guarantee you won't go back.
I've kind of gone back at least, a little bit, because you're like, oh, this, I don't know, some sample, but it felt a little bit harder when you're downloading libraries and
It is,
code.
yeah, you have to put them in a different spot.
Or it just everything you have to get used to anyway. You have to learn, but
It is a little different, yeah.
the benefits are very high because of the autocomplete and all
Arduino is easier to start, the platform IO, and VS Code, if you're doing anything for big or long term, it's way better.
Yeah, if you're doing something like quick, it's like, it's hard to beat, boot up Arduino IDE, you got your three functions, your two functions, you paste and you hit upload, and you plug in, upload, and you're done. It's sort of small and compact, and the code, but if you're doing a lot in code already, then it's just like, oh, there's another plugin, another, I'm in code a lot in Microsoft Code for Python and everything else, so it's just another little add-on plugin. But yeah, I'm still not. Yeah, the more hours you put into Arduino programming, the more you'll benefit from the code.
Yeah, and I guess while I wouldn't argue with that, one of my counterpoints would be is once you have autocomplete and contextual highlighting and access to help and right-click functions, like it makes learning about it so much easier than writing code in Notepad and hitting compile and trying to read it. Anyways, like all roads point to being awesome. So whichever one you do, but yeah, I would. If it's just a matter of a couple minutes, I'm happy to spend whatever time it takes.
Okay, I just made it, yeah.
All right, and so once you have the Flutter installed and you've moved over to Visual Studio Code, what you'll want to do is look for a couple of extensions. So the first one is, and the most important one, is the official Flutter extension, which allows you to do everything through the IDE that you normally have to type in through the command line. Super awesome. There's also, there's a bunch of other stuff. I haven't installed any of it yet. There's snippets files, all kinds of fun stuff. But the main one is this. This is how you get the party started. And if you'd like to see what Copilot has to offer, they have a free like 10 or 15 day 10-day thing where you sign in, you give them your credit card to start the subscription if you like it. Go ahead and get that started, and then you can add in the 2 Copilot extensions, the main Copilot for autocomplete, and then the chat function, which allows you to select code in your code window and then have a conversation about it in a chat window.
Those are 2
to your
separate
left.
things.
Yeah, yeah, you'll want to install both of those.
$10 a month, huh? I have friends that have already been using this for months.
Yeah.
But I have not wanted, I'm old. I want to get younger, so I should sign up.
Now the one that I'm adding in at the last minute, so I'll highlight it here. So here I'll copy and paste it into chat. Is FlutterFlow. So one of the things you don't get out of the box is a WYSIWYG UI drawing tool. And in the beginning, at least, it was fun to draw things and look at the code as part of my way of learning. Okay, I don't have it signed in yet. Let's see if I can sign in real quick. So FlutterFlow.io is a web-based, this is just me Googling, is a web-based UI designer. So you can, once you get your bearings, which I'll show you next, so you understand how the language wants to work, then you know how to apply the UI elements, and you can drag and drop and set just to see how they look. And when you've done that, you can view the code to see the code that it generates. So you can develop entire applications this way. I'll be honest, after I got my bearings, I haven't really come back to this at all. But to get a feel for how everything fits together, it's certainly something worth bookmarking to help you get your bearings on how all these pieces fit together. FlutterFlow.io allows you to visually describe UIs, and then you can generate programs if that's how you roll. The next thing is on YouTube. There's hundreds of thousands of hours of video out there.
Already?
Lots of great, lots of great creators. This is the guy that I settled on because he talks with it's not an Australian, it's the other one. Sorry, I don't equate them at all. New Zealander accent, maybe it's Australian. Don't tell him I can't tell him. He's easy to follow. He talks with a cadence and a speed that makes you feel like you're not rushed. And this guy's prolific. There's probably 100 videos. He's got ones that specialize on an element. He has a series that describes writing certain types of applications. Mitch Coco is certainly someone you want to bookmark to get your bearings with. Now, with that, he's got 2 videos that I would recommend you sit through. I don't think this is it though, hold on. One of them is a 44-minute Flutter beginner course. And he not only takes you, before you even get to the UI element.
Welcome to the Flutter beginner course, but
he walks you through some basics of the Dart language. So at some point, you're gonna have to pay your dues, right? You're gonna have to spend some amount of time to get your bearings in the language. There's a 45-minute version of it, which you definitely wanna sit through. There's also a 2-hour one. Let me see if I skip past it. Okay, I did skip past it. There's 3 links here. Ben's going to copy all of them in. These were all written within the past couple of months. There's also a 2.5-hour one, and it all depends on how quickly you're picking it up. The 2-hour are very thorough. Again, get your bearings, pay your dues. Fireship published, what was this, last year? A 12-minute boot camp. This is the one that I would start with. At the end of 12 minutes, you will understand exactly how the components fit together, and then that gives you that gives you the background to absorb one of the other two, and then to start diving in. The other resources that were handy was there's a widget catalog, which is a tab that I always have open. That just, it's a nice way to scroll through to remind yourself what's available, because you don't know how you're going to write it until you know what tools you have. And this is a catalog of all of your UI tools with explainers and sample code and click through to the class description, exactly how to use it. The last bookmark that I always have open is called pub.dev. There are thousands of extensions, widgets, classes, modules, components that you can leverage that people publish to that you can use in your own package, in your own packages, or in your own projects. For example, before I got distracted multiple times, I wanted to see what OpenAI packages were available on PubDev, and it turns out like a dozen people have written various integrations with OpenAI through REST. Some of them have been upgraded more often, some of them are a little bit behind, some are more geared towards LangChain integration. I haven't seen any that support the text-to-speech API extensions that they released this week, but I'm sure it's just a matter of time. So these are most of the tabs that I have open off to the side as I'm going through it. So to kind of wrap up our whirlwind introduction to Flutter, let's get back into Visual Studio Code, and let me show you what a workflow looks like. Let's go back to the things here. So once you have everything installed and configured, there's a keyboard shortcut for this, but I can never remember what it's called. So I'm going to go to View, Control-Shift-P, of course, how silly of it. To Command Palette and type in Flutter. And you've got some shortcuts to Flutter Upgrade to make sure that your Flutter installation is up to date. Flutter Doctor, make sure everything's installed correctly. Now, assuming we've gone through and installed the Flutter SDK and added it to our path and followed all of those instructions on this page, you can go to Flutter New Project. Uh-oh. That's disappointing. Hold on, let me retrace my steps here for a minute. There's a chance that I had Flutter installed and set up under, oh, well, let's just do it. Nope. All right. So we'll get a little bit more hands-on on the Flutter install this morning. Let's go ahead and Flutter download the zip file. Actually, what else we could do I'm gonna move over to my workstation. No. Hold on, I'm fighting with the window right now. All right, so we're gonna jerry this a little bit. I'm logged into my workstation in the other office over here just to move the conversation forward with a properly installed and configured Flutter install. I'm a little embarrassed that I missed that when I was preparing yesterday, but say levy. And then palette, Flutter new project. We'll do an application just to give us something to play with. It wants to know where you want to put your project file. And so I've got a projects folder. Let me resize this so we can see both sides. Almost there. All right. So we'll put it in projects. We'll call it RSC Hello World. And it goes through the script to create the entire project structure for you in the background. Okay. All right, so we selected a basic application, so it's got a window and it's got a counter and stuff. Once you've gone through the tutorials, you've got your bearings. Just like in most other C and C++ languages, you've got a void main. This is where the party starts. This is where everything gets kicked off. In Visual Studio Code. Hold on, my big head's getting in the way. There for a second. Oh, I can't see it. Right there. You're not being helpful. All right. Trying to get everything fit in the window so you can see it. All right, in the lower right-hand corner, from within this, Flutter application context, you have what you will compile for. It defaults to where you're at, so it's saying, oh, you want a Windows app. Go ahead and click here, and you can say when you hit compile and run what your destination is. Because this is on a Windows install, defaults to Windows, Chrome or Edge. And because I have the Android emulator stuff installed, the Android emulators that I have defined will also show up here. So I'm going to go ahead and select Chrome, Chrome. And so now Chrome appears down here. And I'm just going to go ahead and click compile and run. This little debug and arrow here in the upper right. And the compile and launch step takes about 20 or 30 seconds, depending on the size of your app.
This is a small app, right? A simple app. The larger ones might
Probably take longer, yeah. All right, so let me go ahead and resize this a little bit. So here is our app. Let's pretend like we're developing something for.
Does it have its own web server or something?
Correct. Yep. Yep. So localhost on a defined port. Because I selected a basic application. Here's what it generates. Let me get this over here for a second. And this is your kind of your hello app. I'd recommend everyone run this first to get through the compile and run step. Web page.
It's that red thing in the corner said.
It says debug. Yeah, so by default, there's a flag that it sets, and that's actually one of the first things that we're going to change. So Flutter app is on the right. We've got live debugging and all kinds of stuff here on the left. Let's make some more room. All right. Sorry, I'm fighting with, slide my big head over there for a second. Okay. All right, so the app is running. You've got a couple of things up in the action bar on top. We can stop it. We can reload it. We can hot reload it. For a lot of your changes, you won't have to click on any of that. And that's what we're going to wrap up this talk this morning, is as you make your changes and hit save, it'll attempt to compile and push the updated code directly to your destination. So again, iterating is very quick. If you have a syntax error, it'll be highlighted in red, and then nothing will change. So scrolling down, color schema, my home page, class home page state, widget build. So there's some pieces of the app. We have the scaffold and the app bar. Let's see if I remember where to do it. I think I can stick it here. So I remember that debug bar has the word debug in the flag. So I'm going to type in debug. Now I noticed that the IDE autocomplete doesn't support that, so that's in the wrong spot. So let's look up a little bit. Let's try up here. Now I've got an autocomplete from Copilot, but I don't have the IDE is not autocomplete for me, so it's still not in the right spot. So let's do this. Now remember, I could look it up. I could do a search, but I'm going to be super efficient about this. And let's move to with my turbo in Flutter. How do I remove that darn debug flag? I can't remember. That didn't help. Not helpful. Do I remove it during debug? There we go. All right, let's try that. Okay, I can remember where to stick it. So, all right, so in the minute we have left, let's go ahead and change something so we can at least see it work live. So we've got an app bar. The app bar has a background color. Let's go ahead and use Copilot to give us a hint. Background color. Make a liar out of me. All right. Oh, there we go. It auto select offers color.green. I'll hit tab to accept that, and we'll hit save. And there you go. So the talk was a lot less like how to be awesome in Flutter, more about the tools. Using these workflows is making me at least 10 times faster. We're going to make a time card and a work order app for our techs over the next 2 months. And eventually I'll start using my free time to write the ChatGPT app for my personal generative AI that initially got me into this.
So if you didn't use Flutter, like, what would be the traditional approach to your application?
So there are a bunch of different application frameworks, right? If you are running it for Android and didn't give a hoot about Flutter and else, then Android Studio would allow you to do a native app in
Java, yeah,
Okay.
a lot.
in their Java derivative. Yeah. So same thing with iOS.
Do you think this makes it easier?
From where I'm sitting, it looks easier even for the Android app for me. But then on the work side, in order to get an iOS app in the hands of my techs who use iPhones, first off, I've got to buy a Mac. Not a big deal, but an extra step, right? And then we have to pay $100 a year for a developer license. At that point, I would like to assume, once all this is installed on the Mac, I hit give me a Mac app and it generates a Mac app. But you just can't give a Mac app, an iOS app, to an iPhone and have them run it. It's a walled garden. They take those things rather seriously. So you have to publish it to the App Store. Normally, once you publish an app to the App Store, it has to be reviewed and approved, and then it's available for anyone, which is less optimal. If you're an enterprise customer, you can publish a private app to be made available. And I think our campuses they use an enterprise tool called Jamf. So anyways, it's not to say it's impossible, but there's a lot more hoops.
So this way you can get around all of that and just directly
Well,
create
that's,
an iOS app?
yeah, so if I don't want to go through that, I can publish this same code base as a web app, and then I can hard code a shortcut to the URL on their phones,
Right.
and it's almost the same experience.
Oh, I see.
So you don't have to make an
Yeah.
iOS native app.
Yeah,
And
so I
go through
can,
that whole.
in the
the
short
web app.
term, I can deploy the web app,
Which
and
is-
then at some point, if we see a business need for it, we can go through the.
Oh, hey,
steps for it.
hey,
I see
I
that.
did,
So-
I did.
All right.
Long trip for you.
All right, so that wraps it up. I'm happy to share with you guys what I do in the next couple of months. And hopefully, if I can start focusing on ChatGPT again, I'll be able to show off my personal ChatGPT Android app. So,
Oh, one question on, well, I would say portable environments. At my work for years, we've used Qt or Qt,
Right.
which is a famous one. It's native programming, C++, but it's like POSIX compliant. So you build this thing in Qt. It's got a GUI editor if you want to use that, and then
I think we use the same thing at my work.
it compiles under Linux, under Mac, under Windows, no problem. I don't know about about Android. Yeah, I guess maybe nowadays, I don't know, but this seems to be like a future sort of evolvement from that sort of Qt and Qt Creator is this a native IDE building environment. I guess you could use other languages too, but maybe Qt has Python embedding, or what do you call it, attachments. But this system is maybe, I don't know if you've had it. It's maybe a little bit more evolved than the Qt environment it's like the next level.
Yeah,
Is that what you would say?
Qt is a UI toolkit. I've done a lot of work with Qt under Python for my ROS work. So Qt is built on Java and Java's promise of write once, running.
But it's not just Java. The whole Qt has native. Qt Creator is a complete POSIX build environment for code.
Okay.
For complete code. Everything, the full stack all the way down to to driver level, well, to basically any code you want. And then there's a UI portion of Qt has a user interface development, set of classes or whatever and all that are portable to all the platforms. But underneath there's a whole set of fundamentals, Qt list, Qt or Q list, Q, of all the data structures you ever want in computer science. So you can build full apps, full complete apps that will build natively to all that, and then if it builds with the Qt classes, if you stick to those, then it's highly, highly portable. Or you stick to, then it will build under Mac and Windows and all that. Because as then you have to install that Qt and build environment on those different machines. But in other words, it's much more than UI. It grew, but this new system you're talking about seems like it's a bit more easy to use, and
It was a lot of fun.
beginners and stuff.
It was fun enough that I was working on work stuff after hours, like that kind of fun.
Yeah. So,
I will install it when I get home.
Yeah, but I'm thinking, for me, it's like I never installed Qt at home. It was only for work because it's like too much overhead. But this system is like something you can install at home and you won't have that complicated.
Yeah, Ben, are you having fun with it yet?
Okay.
Flutter stuff?
You already got him on in
One of us.
Thank you.
All right, guys, thanks, and I'll have to keep you posted as it progresses.
All right. And you just learned about it a month ago, or?
All right, so, just a quick reminder, if anybody online has a show and tell, let me know on chat, so I can add you to the list. And the next up is Chris.
Have you enabled screen sharing? I cannot
Yes.
screen share.
Oh, yeah, you should be able to. So it looks like you are, okay, so you're using the web version. I don't know a lot about the web version.
So I could try to leave and come back.
Yeah, so screen sharing is available through the, I don't know, is that a limitation of the website? No. I said share. Could I sweet talk you into installing the app?
Yes. Do a show and tell and stuff.
Okay.
Are you able to share?
Yeah.
Only share if you have the full. I don't know, well, no, he's not. We don't use the mic, and the mic is there, and the audio is all there. Oh, you have your Zoom app?
Well, I was using the web app.
All right, guys, so apologize, we're gonna get set up here in a couple of minutes. So while we're getting set up, I'm gonna monologue for a minute about what's happening on the humanoid robot side. Go ahead and share my screen again.
That's a problem.
I
have an old computer. I unfortunately have technical issues. Is this
So there
that
are,
app didn't work? Is that what happened?
there are a bunch of humanoids on the horizon. I'm sure we're all tracking
You can copy all your
Boston,
stuff to my PC.
oh yeah, Atlas. They've been working on him for a very long time. He's hopefully they'll eventually make him into a product, but until then, he's awesome to watch, and he's doing cool stuff all the time. Of course, Tesla has their Optimus. And as much as I like to bash on Tesla and stuff and their silly costumed anorexic person, they've actually made a huge amount of progress over the past 2 years to go from an idea to a walking robot and teleoperation manipulation of tools. Apparently there's no web pages about it. It is just Wikipedia. It is truly impressive. And in some locations they have mock-ups of their bot. I'd love to find one locally and check it out at some point. So I'm not counting them out. They're also up and coming.
I
In
saw
the-
one in person, like, there was one in a case in person at a store in a mall, or at, yeah, they have one, where was that? It's in the Tesla, the Tesla store in Santana Row.
Okay.
But I saw one at somewhere, somewhere else. Yeah, it was in a mall, I can't remember now. But you could go right up to it.
Another one that's going to be
No,
made
it's in a
available in the
case.
short term is Agility Robots Digit. So this started out as a mobile platform called Cassie. And when I say it's going to be available shortly, they recently completed construction of like a 50,000 foot manufacturing facility. They are going all in. These are being produced, and apparently they have use cases and customers lined up. So of the top three, this one's going to be available for purchase either this year or next year. They're going all in, and you don't build that large of a facility and not have a product. So
Do you know what their use cases are?
I think Amazon bought a bunch of them.
Oh,
It seems like there's a lot of competition now. People are competing with each other.
I wonder what the battery life on these things are. They go 2 hours and recharge, or?
I didn't bring my good one.
Yeah, I don't know a lot about them.
I would copy.
I'm thinking of putting up a portion of our website to try to keep track of them, because there's about a dozen. Those are the most exciting ones. The rest of them are all variants of, and I'll just pick on Unitree because they're claiming to be close. There's another 6 or 8 players that are using low gear reduction BLDC motors in all their joints, and they're all producing variants of this style. So altogether, there's got to be about a dozen of them.
There's also Kind Robotics, which is part of our group up in the.
Kind, KIND.
Yeah, and that does not use quantum director.
Yeah, and this is exactly why they're going to take over. If I was treated like this, I would take over.
Well, you've seen the Boston Dynamics, spoof video of
Yeah.
the robot with the spot, or it was Atlas takes the gun and.
So rude.
Yeah.
And so, yeah, there's probably about 6 or 8 other quasi-direct drive ones out there. I think I'm going to set up a corner of our website to try to keep
Do you have
track.
any opinion on why the humanoid shape? The Boston Dynamic dog, I've been to a presentation on that, and I've seen the dog and whatnot, and she's really good at walking upstairs and through the gravel and stuff.
Yeah.
What's the advantage to the humanoid shape?
Well, we're human shaped, and most of the things on the planet are human shaped, and probably our egos, right?
We're gonna get your talk on.
Humanoids are.
Maybe it interfaces with things that are built for us.
Yeah.
It's like.
Yeah, somewhere between why because we can.
You gotta
and-
have your toolkit.
And there, so yeah, even in the human robotics space, the next couple of years are gonna be exciting. The fact that Digit went from a legged platform to a robot in, what was that, 4 years? I want them to come down in price to where I don't have to mortgage my house to get one.
The Boston
I want them so
Dynamics,
bad.
I tried to write a use case for my company for the Boston Dynamics dog.
Oh.
It's $100,000.
Yeah.
The basic dog.
You don't have to buy a quadruped that's $100. I mean, I have a quadruped that's pretty cool, and it uses quasi-direct drives, and it was $6,000. Unitrees are down to $3,000 and $4,000 for something low. And there's going to be even more as the competition kicks up. China is definitely going to be producing some pretty cool robots. The reason I brought up Kind, which is sort of in its early development, is they're looking to hire. So if you want to join a company that is starting a humanoid company, take a look at it.
He's
Not like
is always
Tesla bot or
his
something where you
computer's
never
the
can
one
get
that's
in.
projected on that screen. But
Hey
you're-
guys, I'm hearing a lot of cross conversation.
Oh, that's Thomas.
Hi.
Thomas, you're very low.
Thomas, raise your mic, please.
I do not.
Well, that's not good.
Oh, so
Okay,
I'm now
Chris-
sharing.
Chris is ready.
All right.
Take it away, Chris.
Yeah, my apologies. Following that presentation, I almost feel, because I'm going to the other end. I mean, he's talking about high end. This is the penultimate in AI today. And I'm going all the way back to 100 years ago when AI was, just the glint of an imagination in somebody's mind. And
Jeffrey Hinton.
so I'm gonna call this the ghetto AI and robotics talk. And to show you, I even brought a laptop that was Windows 7. It didn't work, so we had to quickly copy the data over to Jim's computer. And I cannot see my own files here. There we go. All of this is on a Google Drive. And unfortunately, because I'm not on my computer, I cannot post the link right now to the chat. But anyways, I wanted to talk about the intersection of two things that has always excited me. And of course, the first is robotics. This is a robot group, and everybody knows who this guy is. And he's responsible for getting me interested in robots because of all the cool stories he wrote.
I'm sorry, that's, you're good at saying who he is.
Isaac
Isaac
Asimov.
Asimov.
And now again, I cannot show PNG files on your computer.
Oh, yeah, you can. You just
How?
click,
Um,
here we
yeah,
go.
and so Isaac Asimov, I hope everyone's heard about him, but
Yeah.
he wrote a lot of robot stories, and he's famous for the 3 laws of robotics. Basically, don't harm people, obey what people tell you to do, and don't kill yourself. And so this is just a humorous cartoon about his stuff. Another guy who really influenced me and got me interested in artificial intelligence is this guy. A lot of people don't recognize him. His name is Martin Gardner. And he wrote a column in Scientific American called Mathematical Games, I think. And I just loved math and games and puzzles. And one article that he wrote, which was republished in one of his books that I would read, really caught my attention because it was, I think I have, I lost my, he wrote an article, I think I have a copy of it here, on how to build a game learning machine and teach it how to play. And I thought, wait a minute, you can have a machine that's intelligent and actually learns. And I thought this was really cool. It's a great article. Again, it's in the Google Drive, which I'll post a link to. But he invented this new game called Hexapon. It was basically a super mini chess. And the idea was really simple. You would take a bunch of matchboxes, and on each matchbox, you would represent what the state of the current game was. And you would put different colored beads that would represent the possible moves that the computer would make in that particular position. And the idea was you start the game off and you select a randomly colored bead and the computer makes that move, and then you make your move, and then it goes back and forth. And of course, it's probably going to lose because it doesn't know anything at the end. But the beauty of this is the reinforcement learning involved. If it won accidentally or on purpose, you would reinforce that behavior by adding another colored bead of the same type for each of the states, reinforcing, so the next time it gets into this particular state, it's going to statistically do that more often. And if it lost, you would penalize it by either adding more of the other colored beads or removing that bead, so it wouldn't repeat that mistake. And it learned pretty quickly. It's a simple game, so I think after 11 losses, it slowly learned to play a perfect game. And I thought this was totally cool. And so, of course, I didn't have access to matchboxes. And he tried to apply this to like mini checkers, mini chess. And it was just a really cool thing. So
What's the vintage of this? This is, we're talking about
uh,
the 1980s?
70s,
Late
60s.
So using neural networks?
It wasn't using neural networks. It was just simply matchboxes and beads. If you would just randomly play, and so I didn't have matchboxes, but I had a lot of these, egg crates. And I also had a lot of these, colored beads. It's great having sisters. And so I decided I'm going to do the same thing. And so instead of matchboxes, I would fill these egg crates with different colored beads, and I would make up my own games. Of course, I did hexapon, I did the mini chess and mini checkers, and I thought this was so cool. And I remember announcing, I'm going to solve checkers. And so I figured out, well, why not? This will work for any particular game. And so I started really simple. Why it worked for mini checkers, why can't we do real checkers? And so I started getting egg crates and beads and writing out, and I pretty soon realized, oh my God, checkers is just too big to make a learning computer out of beads and matchboxes. Ran out of beads, ran out of egg crates. What's really cool, it's sort of sad because somebody else actually solved checkers first. I wanted to be the one to do it. This is a really good book by Jonathan Schaefer. He worked, I forget which university he was at, but he decided he's going to solve checkers. And one of the AI techniques that was popular in the day was simple minimax algorithm. And minimax was applied to chess, to checkers. And the idea is, going back to this, it's you assume if everything in this row, if I make this move, what can my opponent potentially do? And I want to minimize the damage that he can do at, say, this level 3, and I want to maximize the score that I can get here at level 2, and so that's called minimax. Lots of advancement in this, alpha beta pruning, lots of heuristics, a lot of chess programs were written, and he eventually solved checkers. But just to give you an idea of how big that problem was, here we go. From his Chinook page, just looking at the total number of positions in checkers, I don't know how many tons of egg crates it would take and how many beads to do this, but we get, I can't even pronounce this number. Here's billions, trillions, quadrillions, so like 500 quintillion positions in checkers. It's a lot of beads. Now, what's amazing is the fact that he solved this in the sense that for any given position, Chinook will play the God's perfect move. And you might ask the question, well, with so many positions, how can you have a database this large? It turns out using alpha beta pruning for a minimax search, you really only need the square root of the number of actual positions because you can quickly eliminate most of the data. And exploring branches where you make a stupid move just get eliminated because you realize quickly, if I make this stupid move, I'm going to lose, so I'm not going to do it. So you don't really have to enumerate the entire search space. As an aside, I know there's lots of different definitions of what artificial intelligence is, and one that I like is minimizing searching the entire search space to find a very, very good answer. And most problems that we apply AI to, there's huge search spaces, and you can't brute force it. And so I like the idea that intelligence is not brute forcing and coming up with something clever to solve a problem that ordinarily would be absolutely impossible. So really quickly, I'll show a picture of different AI categories, and mostly to illustrate that what's the difference between AI and ML is a common question. And the simple answer is machine learning has the word learning in it. Artificial intelligence is intelligence. It does things that are smart. And examples are things like a simple PID loop is artificial intelligence. It takes the entire search space of what's every state that this system can be in, and I'm going to decide to apply to some motor or some, based on feedback with a simpler algorithm, so I don't have to exhaustively decide what I'm going to do in every situation. I'm going to use this intelligent algorithm to do something a little bit more smart. Alpha beta pruning for minimax search is another example. Learning is that's what it is. It's you're doing something, you're getting feedback, and you're going to change. And this gives some ideas of machine learning. Now, this inner circle, deep learning, I personally don't think should exist because it doesn't really do anything. It's not a paradigm shift in any way whatsoever. It's just we're learning a different way. And there's a lot of different ways to learn. Lately, everybody's with LLMs and neural networks, but that is not the only tool in the toolbox. And so today I'm going to talk about two of my favorites, Bayesian recognizers and classifiers and genetic algorithms. And the reason I like them is because they're simple. Like I said, this is the ghetto talk. And you can write software that will run on low-end Arduino Nanos that can do genetic algorithms and Bayesian recognizers. You don't need super cloud computing to do things, which is why I like it. So let's first talk briefly about what a Bayesian classifier is. And this is back in, when was this? 1984. They decided that, oh yeah, AI is kind of cool and we might want to turn this into a regular conference because it's getting popular. So 1984 was the first annual AI and Advanced Computer Conference. And I was working at a company at the time who was using AI for devices. And they asked me to write a paper. And so I wrote a quick paper, and it was basically, this is how a Bayesian classifier works. The company I was working for was really interesting. It was called Stellar Systems.
Single click on the machine.
No, single click. Okay, how do you open a WebP image?
You try photos.
Oh, hey, here we go. And what they invented was a little device that you put your hand on it, and it would measure the length of your four fingers, and based on just those four pieces of information, would identify who you are. And you wouldn't think that's sufficient, but it turns out it was pretty accurate. It was between like 98, 99% accurate, which was good enough for most applications. I think I have another better picture of it. Yeah, here's a better picture of it. What's interesting is I was looking last night for a picture of this, and this is called Lazar Identimat Hand Scanner. This is the one I worked on. Bob Lazar is a UFO nut.
Did he get abducted?
I don't know, but what's interesting is there was a video of him talking about Area 51 and how they had to use these biometric hand scanners to get in and out of Area 51. So I thought that was pretty cool. I didn't realize that something that I had helped invent ended up in Area 51, but darned if I ever got an invite to go install it.
So the aliens with the 10-inch fingers, they could.
Exactly.
Yeah, that's what I was convinced.
Maybe it was designed because I could tell humans from non-humans. But the idea behind it is double click. The idea behind Bayesian or statistical classification is actually very simple. And here's a slide showing an example of 3 different, say, people or classes. And the idea is you take a number of readings, and here I think we've got like about 8 to 10 samples each of red, blue, and green. And the idea is you just simply take the mean and standard deviation of a particular feature. And then once you have this data, when the system's in use, you go and you take a reading of some unknown person, and you see, you can see my mouse, and if it falls in this area, then you know, oh, you're the green guy, or you're the blue guy, or you're the red guy. Now, interesting to note, when you use more than one feature, sometimes if the features are highly correlated, an additional feature doesn't really give you that much additional classification or distinguishing power or performance. And especially like if you're here in between the red and the green guy, for example, you might not exactly know who it is. Now, a simpler algorithm is called, like, for example, KNN. They just call it the K nearest neighbor. And the idea here is you take a sample and say it's where my mouse is, and you just say, okay, what are the 4 or 5 closest other values? And here it's red. And if you're in between here, it might say, well, it's probably the red guy because I see 3 reds closer than 1 of the greens. KNN works great. I love it because it's simple. It's just a few lines of code. However, you now need to store all of your data. So what the Bayesian statistical classifiers do is they take all this data, they throw it away, and they just say, okay, I just want the mean and the standard deviation. I just want 2 numbers. I don't want to care about anything else. And so it's an optimization that trades a little bit of accuracy for not having to store a lot of data. I think I have a picture. Yeah, here's an example of using 2 different features. And so basically now the idea is you have a circle or an ellipse, and you measure whatever it is you want to measure, and you look it up on the axis, and you see, is the point inside the red circle, then you're probably the red guy. If it's outside the red and the blue, then it's, well, you're something I haven't seen before. I don't know what you are. And the reason I'm showing this is because most of the classification systems are not in 2 dimensions. They're in like 20, 30, 40 dimensions, because it depends on the feature vector of what it is you're trying to measure. Now, a good example of this is a program that I wrote. Let me see if I can pull it up.
Just use, you don't want to right click, you can use or Notepad.
Notepad is good. I hope this font is good enough to see.
You can increase mouse control.
Okay, there we go. But the idea here is I wanted to test something really simple. And so I decided, why not use the timings between keystrokes to identify who's typing? And this is really, again, this is a really small program, and I like this because, again, this talk is ghetto AI, and I want to encourage people to do this at home on your own. And this you can borrow and modify to your own heart's content. The idea is I told everybody where I was working what my password is. And I said, but I defy you to log into my computer even though you know what my password is. So I set my password to "this is my password!" exclamation point. And so the number of features, because there's 21 characters, there's 20 timings in between those keystrokes. And so basically we now have a 20-dimensional feature vector. And so the template is just, again, we're just storing the mean and the standard deviation of each of those 20 features. We're not going to store all the data. And the first thing we're going to do is we have to enroll. And enrollment is similar to those red, white, or red, green, and blue dots, we're going to make you type the password 5 times. So I typed the password 5 times, and we're just in a loop, wait for the keyboard to get hit, and then we get system time, and then we add up, and then we store how many milliseconds between those keystrokes. And then we compute the template, which is basically what's the mean and standard deviation for these 20 features. And we end up with 40 numbers, the mean and standard deviation of those 20 numbers. And then we're going to try to break in. And so we just say, please enter the password. And then we let you enter the password, and we're in a loop for 20 keystrokes, and we're going to get the system time, and then we're going to decide, is it you? Again, really simple. We determine how many standard deviations are you away from Chris Meyer's typing cadence, and we want to see what is the distance from the mean. And then you can set, okay, a distance of 1.0 or 5.0, and it depends on, do you want it to be convenient where I might accidentally not be recognized myself if the tolerance is too tight, at the expense of maybe some imposter. If you loosen up the tolerance, an imposter has a better chance of accidentally matching me. But it worked. Nobody was able to log into my computer. So go ahead
and you were.
and I was.
Reliable.
Because,
Unless you made a mistake and you had to hit backspace.
even if I made a mistake and had to hit backspace, it actually learned where I made the mistake. And it turns out I did. That's a good thing to point out. But this is my password exclamation point. So the exclamation point required me to reach over and hit the shift key. And I'm not a super typist. I'm one of those 3-finger typists. And so hitting the exclamation point at the end, for me, sometimes I would miss it. But the beauty of it is the standard deviation of that particular feature was very wide. So even though I would have a wider variation of timing for that exclamation at the end, the beauty of this is it automatically adapted because it's based on statistics.
In other words, it wasn't tight for that.
Exactly. So each feature is going to automatically tighten itself to the accuracy of what your enrollment data is.
And so, yeah, but the rest of it was tight, was as tight as.
As tight as I could type.
Right, so an imposter could probably easily do the exclamation point easier
Yes.
than the rest.
Yeah.
But he has to do the whole.
Yeah, but because you're trying to find a point that's encompassed in a 20-dimensional hypersphere, only one of those dimensions is really wide. So you still have to get the rest of them really tight. So that was a lot of fun. So that's a quick overview of how simple Bayesian classifiers are, statistical classifiers, and a simple program that you can use to play around with it. The next thing I want to jump to is genetic algorithms. Genetic algorithms, again, are really easy. And I have some examples here. Really quickly, this is Watson. It's a full-size biped that Dan Albert was working on, and I met him, what, a decade ago? Yeah. It's been over 10 years.
It doesn't look anything like that today. That's like model build 3 or something.
Yeah. But it was a cool robot. And he had the hardware, and when I started actually at HBRC, I was a software guy, and I thought, hey, this is cool. I want to meet up with some guy who has hardware, because I don't want to build the hardware. So we spent some time trying to get this to walk, and I had the great idea, well, geez, he should learn how to walk by himself. We can use a genetic algorithm for this. Of course, he was reluctant to let me put untried software on this robot that cost thousands of dollars to build.
And broke really easily.
And broke really easily. So we built Mini Watson, which was similar. This is just a 16 DOF Robo 1 biped. And this was, I think,
Circa 2005.
2005, yeah. Well, you'll notice that he's missing part of his left arm because, yeah, you do break robots when you run untested software and you're trying a genetic algorithm on it and it's doing random poses and it will break itself. But it was cheaper to repair this than Watson. And then we decided, well, why are we breaking this guy? Let's do it in a simulator. So we did it in a simulator. So the first thing, and I'll show a quick video. Double clicking is not running the video on your computer. How do I
Hit
run it?
enter. Highlight it, hit enter.
Open with,
Like, use NPV.
okay. Let me hit pause because I want to highlight that.
Okay, on the left.
There we go. So the idea here, and you'll note that the simulator version is also missing the same arm. That was done purposefully because the idea was he learns in the simulator and then you put that data onto the real robot and see if it does the same thing. And of course, weight and balance is very important for a physical robot. So that's why the model is missing the same arm.
Which simulator is this?
Now this is VREP. I'm gonna spend 30 seconds to say VREP versus Gazebo. I started trying to do this in Gazebo, and after a couple weeks of banging my head against it, got very little, and then someone suggested VREP from Capella Robotics. Within not knowing it existed to this demo took less than 4 hours. That's including understanding it, installing it, reading the documentation, writing a hello world, building a model from scratch, and writing code to control it. So that's
just because it's simpler?
just because it's much more simple. And it's a question of power versus ease of use. I didn't need a lot of power. I'm sure Gazebo does a lot of things that I didn't need, but it got in my way. So this was something really simple, and you can see it was really easy to get a robot that really matched the real robot. So the idea here is really simple. The data that it uses is a simple frame of animation. And if it needs a second frame of animation, it'll add the second frame of animation. So it's basically 16 numbers saying, here's the angle that I want this servo to be at this time, at this keyframe. I didn't even bother to specify the time between frames. I just set it to 1 second. And this was a simple task. And the idea here is it has a IMU in it. At the moment, because it's laying down Z, the Z axis is pointing straight up to the sky. And I wanted it to learn by itself, turn Z to negative. In other words, flip over. Because I figured that's the first step. If a robot falls down, you have to go face down because you can get to a standing position more easily when you're face down. And so here he is on his back. And what's going to happen is he's going to randomly generate a frame of animation, and then he's going to try it, and then he's going to learn from it. And I'll talk while it plays. Yeah, so he does something at random, and now he realizes, well, the Z vector changed by how much, and it knows it wants to negate the Z vector. So it's going to try something to maximize the change in the Z vector. Now, usually genetic algorithms, it's a simple hill climber. It's going to do stuff at random until it sort of accidentally goes in the right direction. So here you can tell, well, we've got almost, what, 80-ish degrees. So it's going to try something similar. And then each iteration, see, it's a little bit more, 90 degrees. And it's going to slightly modify what it's found was the best so far. And it's a simple hill climber. Eventually, it will find a local maxima or minima, depending on how you've written it. So it learned, yeah, bend your legs a lot. So it bent that one, it bent the legs in the wrong direction and had no effect. So now it's going to, oh, there it goes. So it learned bend the legs and bend the legs backwards. And so it learned how to flip over, and that was what, less than a dozen tries. So a simple genetic algorithm, you can learn things autonomously. So the next phase was, okay, great. You learned how to flip over. Now rise up and walk. I'll talk over this one. So this is the same thing, same algorithm. He's standing up, and now the goal is to maximize delta x, delta y, but don't change the z-axis. If the z-axis either goes up or down, you know you fall. So basically, move but don't fall is the simple mathematical definition of success. And so it's going to try things at random. Ooh, accident. And it learned, okay, a little bit. And so now it's going to add the next frame of animation. It's going to do slight variations because it wants to hill climb to do it better. And it slowly learns.
And it's using mutation, just like a normal genetic algorithm.
Exactly.
So it's mutating, and then
it takes the 16 values. For example, it's already learned this first frame of animation is just 16 angles of the servos. It's going to slightly rotate them or slightly change them each iteration to see if there's a better way. Because the z-axis or the z vector is moving a little bit, and it wants that z vector to be completely parallel. And so it's going to try to move and walk.
16 settings for each servo?
For one version for each servo.
Looks like, how many servos are there?
16.
Seems like
Actually, there's 14 because he's missing an arm.
it seems like a lot of combinations.
Yes.
Huge amount of
Exactly.
configurations.
Like checkers, the search space is enormous.
Yeah.
There's a lot of bits of potential animations that you could do.
but it's kind of like you said, it's pruning, and it's pruning every time.
Exactly.
It mutates so that a lot of them are discarded, right?
Exactly. I think there's a better version of this. I have to right click and say open with.
Or you could,
it
should be just
Yeah.
single click.
Here's a similar one. Now, briefly while it's doing this, you can merge these techniques. And instead of just doing randomization to hill climb, I actually put a little Bayesian classifier to decide how you should mutate. And I think this video shows an example of how that made things a little bit better. So it learned that if I spread my legs really wide, I've moved, which is what I want to do, and I've moved without changing that z vector parallel. And so now it sort of learned, and one of the features was angle between legs. Well, that's a good thing to do, so I'm going to try that more often than just randomly deciding what to do with the servos. And it will quickly learn to go spread legs, close legs, spread legs, close legs. So it's using here a Bayesian classifier to determine what is a potentially good genetic algorithm generated random next guess.
Oh, so you're using the Bayesian classifier to reduce the type of mutations in a
Exactly.
sense
So even though it would learn quickly with just the genetic algorithm, using a Bayesian classifier to prune the genetic algorithm's randomization for the mutation function made it learn just a little bit faster.
and that's based on the statistics of
Exactly.
which feature changes went in the right direction.
Exactly. Let me speed this up here. I think towards, how do
And he
you,
does do a lot of repetition there.
yeah, well, because he's learned what worked.
And he tries to go from
And
there.
he'll try to go from there, and he'll do slight randomization to get there, because it's like, oh, maybe I can get there slightly better.
Yeah, yeah.
And you'll notice when he does fall, he tends to fall a little bit slower, because the time issue is how many steps did I take? How far did I get? How long did it take me to fall? And I think this video goes, he eventually will take 7 steps in a row. Yeah, so he tried it, and there's slight variations. And here's a robot, and this is running on an Arduino Nano. So it's not a lot of data. It's not CPU compute intensive at all. Very simple algorithm, very powerful. I was laughing when Boston Dynamics was showing our robot Atlas learned how to walk and how to do things by itself. It's like, yeah, been there, done there, that 10 years ago on an Arduino.
Yeah, they have a server room full of
exactly.
A1000s, whatever.
So Thomas has a question from chat. He was wondering if you could explain genetic algorithms.
Yeah, briefly.
Okay, a brief explanation of genetic algorithms.
We can also refer back to a Dr. Bruce lecture from like 4 years ago, where he did words. He used text, and he had a genetic algorithm that figured out what word he was looking for from random letters.
This is sort of a brief overview of what a genetic algorithm is. And the idea is you have a random population at the top. Now, because we're using a physical robot, our population is 1. But the idea here is if you would try, let's say we had 100 robots and go back to it learning how to flip over. You would generate 100 random first poses. And then you would run those 100 simulations, and now we're here at the evaluation function. And for that particular one, the evaluation function was really simple. What was the delta z? The direction of the change of the z vector. And it would give you a single number saying, here's how we rank these 100 trials from best to worst. And then down here, selection is, we're going to kill off 95 of them, and we're going to let the 5 that did the best survive. And then we're going to take the data from those 5, and we're going to mutate them. We're going to mix and match. And you can get into a lot of details about how to do crossover and mutation, but the idea is you want to make it similar to what you know worked, because they were the top 5, and we're going to slightly modify it. And from those 5, we're going to generate 100 new ones. So each one of those 5 is going to have, 19 children that are similar to them, and then we repeat. And the idea is every time you go through this cycle, you get better and better and better. So Thomas, I hope that is a good, very brief explanation as to how a genetic algorithm works. I actually have the source code to something. I'm going to show you the demo first because we're short on time, and then I'll show you the source code. Motbot. This is a very simple robot. Here's again, I don't know how do you open?
You should just
okay. This is a simple Arduino, 2 yellow motors, and this particular one has a ping sensor. Can I right left?
Yeah.
How do I get to the next image? Oh yeah. And so I have.
It takes time.
Oh, okay.
Or it's graphics.
So this is the version that I decided to put another genetic algorithm, and this was designed to do the tabletop challenge. So it's simple Arduino, 2 motors, and there's these 2 line sensors. So it knows when it's gone off the edge of the table. And again, the word ghetto is going to come up a lot. This is really cheap. You can see popsicle sticks and super glue.
I love it.
Is this a balancing bot or is there
It's
another wheel?
running on a Mott Apple.
Yeah,
It has a
It's-
caster.
it has a caster.
Okay.
I think I have a picture of the caster. It actually won the gold medal at Robo Games.
There it is.
The reason it's called the MottBot is because when I bought the parts from China, the caster didn't arrive in the packaging. And I saw that the height was about the same height as this Mott's applesauce cup as I was eating some applesauce. And so I just glued it to the bottom. And so underneath the heavy part of the battery pack is a Mott's upside down Mott's applesauce container. And people hence christened it the MottBot. So that's how it got its name. But here's all of the instructions on how to build one. And that's going to be on the Google Drive. And so now we want to do the tabletop challenge. And I thought, let's use a simple genetic algorithm so that it can learn how to do the tabletop challenge autonomously by itself. So I got a quick video of that.
This is MottBot Learning with the Genetic Algorithm, Take 1.
So I'm going to talk over my self-talk video. Now, the data here is there's 4 states. Because there's 3 line sensors, there's 4 potential states, whether they're both on, both off, or one on, or the other off. And in each of those states, decides what value do I want to send to the left. So there's 3 numbers per state, 4 states, so there's only 12 numbers that represent everything about the behavior of the computer, or of this robot. And it starts off random, and it's going to slowly learn how to do the tabletop challenge. Now, as it's doing it, as you watch the video, it's important that you define properly, because the first version I said, don't fall off the plate. What you
Don't move.
Exactly, that's exactly what happened. It learned because it realized if I tell the motors to go, I'm going to go off the edge. So move as fast as you can, and you get points for moving fast. Well, it knew. And as the genetic algorithm, that meant you get no progeny, you do not
Spin in a
survive.
circle.
Exactly. It learned how to spin in a circle as fast as it could. So the third version was, so in other words, don't stay in the transition where you're on the table. And that was when it finally did something. The moral of the story there is you get exactly what you
And the points for in transition.
exactly. I actually go faster. But now it's learned, either gonna spin to get back on or back up a little bit.
Like those sensors are off the edge, but it keeps moving.
How this works I said after 5 seconds, stop. And then evaluate yourself. How well did did you stay on the table for the or how long did it live? How many transitions? How fast? Motors?
I see, because it's always recording deaths as.
Well, actually two, because it has in its memory what its previous best was. Try out pick the best of those two, and each generation only really touching one new potential domain. But it's not taking it directly again, it's still
That's all running on it.
now, this is all running on the lowest nano, which is why I love this getaway. You can do this at home and you don't need using the definition of the previous talk, I'm old because I still use it.
Of course, how does it doesn't know. Other styles people.
No,
it could go to any edge and still get points.
It's still good.
Okay, so sounds the other side, right? So then you could say the longest, the
Guys?
longer you go,
Guys, the online can't hear any
One
words.
edge, other edge, and back.
that's challenge number one.
Yeah. But here I'm just going to basically stay on the table and just go at random until you find an edge.
So you've got those two line sensors, how do you know where its wheels is? Are you calculating something for those two?
No, he doesn't.
So the wheel goes after the edge.
We start from the same position. But when the edge goes off, when that sensor
All this robot knows is I'm in one of 4 states, and I'm going to look up 3 numbers when I'm in that state. And those 3 numbers are, I'm going to set the left motor to this value, the right motor to this value, and then I'm going to just do nothing. I'm going to plot this node. And then I have no idea how far I'm going to go or in what direction. And then that many milliseconds later, I'm going to read the sensors again, see what state I'm in, and it's that simple.
When you can back up, it'll fall off the table before the sensor goes in reverse, but
He may go reverse too far and back up off the
Guys, we can't hear a thing.
generating a random mutated text, and then scoring itself.
and you win first place. What about that?
Guys, we can't hear anything.
This robot was doing what it was doing with less than 20 lines of code.
Oh, wow.
And $9 worth of hardware.
Oh, okay, that is impressive.
Yeah, $9 worth of hardware, and I actually think it was 22 lines of code, and they were like, "Oh my god!" And of course, I sort of cheated. I aimed it at the objects, and so it just kind of went straight, scooped up objects, and put them into the shoebox at the end.
Oh,
So
you cheated all the way to challenge
so
3.
it got to challenge 3 through cheating.
But
But they're like, hey, it was a great show.
and not reproducible either all the time, right? Like you had a good run.
Exactly.
Sometimes.
All right, so we have another question from chat from Yoshio. What are the 3 numbers to be evaluated?
Oh, he couldn't hear over the motor noise.
Oh,
We can turn
I'll
off
actually
the noise.
show you the code. Oh, here we go. You don't have the Arduino.
You can open that in
IDE.
the text editor, just right click and
Right
say
click.
open with
Open with.
Notepad++.
Oh, Arduino or
Or any of
And it
those.
would choose
Oh, I
the
do
right.
have Arduino, right?
Or Notepad++. Here you go.
Notepad+ is quick.
So this is the full source code to the genetic algorithm of what you just saw. And I'll quickly highlight, there's actually three. There's a hidden sensor in the center underneath the robot. Pay no attention to that. The reason that's there is because when I initially started testing this, I was having to catch my robot as it would jump off and leap to its death off the edge of the table. And I realized I'm going to have to re-glue this multiple times. And so you'll notice I had a black board with a yellow piece of paper.
If it sees black, it's dead.
Yeah, and
Yeah,
so I
simulated
have
death.
the center one was, oh, when you see black, shut down immediately. So that was my safety way and of saying, I don't want to keep gluing this back together. So that's built into the code. Reading sensors is really easy. Just digital read the sensors. And it's either a 1 or a 0. And then our state is going to be just 2 bits of state.
We'll have to take the comments out.
Yeah, take the comments out. So here's the genetic algorithm. It's really simple. Here's the gene. It's just a left value, a right value, and a time value. And there's 4 different states, so there's a total of 12 different numbers. And like I said, it really simply says, what's my state? Look up these 3 values in my table and set the motors and pause for this amount of time. And then continue. So the randomization was really simple. I didn't do anything fancy. I just said random. It was completely scrambled. I wouldn't completely scramble it. I would only scramble not all 12 of the values. I would only scramble a few of the values.
It's like poker. You take 1 or 2 cards.
And again, it's more art than science. Is it better to scramble 1 value, 5 values, all 12 values? There's, one of those is going to be optimal. And here's the mutation. I think I did the random of a random, so you would get some sort of Poisson distribution of random. So here's the fitness function. I won't go into that very well. It was basically how fast are you going, and did you actually find edges?
And then you gave a number.
Here we go. Yeah, for 5 seconds. So we're in this loop. As long as 5 seconds hasn't elapsed, we keep going. We just loop here, and so we just read the sensors. We get the value, and then we set the motor. And there's probably a sleep command in there somewhere to say wait. And then the iteration, again, I love it because it's very simple. You just mutate. You have the best gene so far. You mutate, create a test gene, and then you score the test gene by calling the GA fitness function, which does this 5 seconds.
So each run is 5 seconds.
Each run is 5 seconds. And then it just says who was the best. So basically, I guess you could say this is a population of 2.
It's just the better then.
Yeah, which one is better? So of these 2, I'm going to kill one of you and create a new one as a mutation of the better one.
So a lot of times they probably stuck with the same one and then mutated it again.
Yeah.
And like that was a bad mutation. I'm just going to redo.
Just redo the old one.
Yeah, and then sometimes it would go, oh, this is better. I'm taking it.
Yeah. Now it wouldn't actually redo the run because if the best had, say, a score of 7, and the mutation came out 6.9. It would create a new mutation and run that mutation.
Well, that's what I mean. It always is creating a mutation, but it was creating a mutation off of the same one twice in a row.
Yeah. So that's it in a nutshell.
So
that was a really brief overview of genetic algorithms that you could use on an Arduino on a simple robot for $9, and how you can play around with Bayesian recognizers to just do really simple statistical things and get really, really amazing results with just zero CPU and zero data and $0.
Thanks. We have another question from chat from Thomas.
Yes.
Do you save the data after each run, or do you start from scratch every time you turn it on?
Every time the Arduino power is on, it forgets everything, which is why you'll notice that I'll talk while I'm running that.
NVRAM or something to remember it.
I'll just, for fun, run some other videos. Using the same algorithm, this was a competition that I entered in with, was trying to get drones to autonomously fly through obstacle course.
Yeah.
And using a simple genetic algorithm, again, using a Bayesian recognizer to realize what's a good way. And it had this sequence of gates that it had to fly through. And it was just the control of this drone. Again, it only controlled the speed of the 4 rotors of the drone. It had an IMU feedback, so it could tell its gyro and accelerometer to figure out where it was. And okay, here there, it crashed. So here's a version.
That's a real drone, or?
No, this is in a simulator.
Okay.
Which simulator?
This simulator is called Flight Goggles.
Like, oh, that's what
And you'll notice, see right there, you notice the drone rotated before it got to the gate.
Yeah.
Because it learned, oh, this is a really sharp turn. And it started off, I go through the gate, and now trying to make that turn, it didn't work. See here, it's trying to find this gate, it's trying to turn, oh, I can't get to the gate. Ignore it, I'm gonna go to the next gate.
How does it know which gate to go to, and how does it know that
Colors?
it actually went through the gate? Or that part
The
of it,
gate
like-
sequence was given to it, and the XYZ coordinates of the gates were given to it.
Okay,
So it just knew I have to go through these gates in order.
and the XYZ coordinate as well.
Yes, because you're a drone, so you're in 3 dimensions.
Yeah.
So it took it a while. I want to show that again because
This had a few more numbers involved, right? Because you
yes,
guys talk
quite
about
a few more.
talking about
Again, I'm double
10
clicking and
yeah.
it's not playing. How do I play
Just-
the video? It's
Just
kind of
single
there we go,
click.
yeah.
Single click.
So it finds the first one. So here's the gate with the sharp hairpin turn, and you'll notice it actually turns. It learned that its momentum will carry it through the gate.
Oh,
And I thought that was cool.
that's what real pilots do.
when
I
it
think.
learned
Know
how
about
to
the
do that.
obstacles?
Pardon?
Does it know, can it see those obstacles?
No, it doesn't know. It has no data about the obstacle.
It only knows.
It only knows where the
XYZ.
gates are. It only knows where the gates
It's
are.
probably the middle of the XYZ's in the middle of the.
Yeah,
the
so
gate.
it does crash into obstacles, and it does learn, oh, I missed it, so go on to the next one. Because it realizes it's scored for how many gates did you make, and what is your time. And so it learns, for example, is this the one, where's the one where it kept circling around the gate and it just couldn't get through it because of momentum?
Yeah, then it
And
runs
then
through.
after a certain amount of time, it realized, I'm losing points, let's go on to the next game.
Wow, that's quite.
But that's,
invention.
that's why I want to impress, with such a simple algorithm, with a few lines of code, you can get these really beautiful, complex behaviors without, again, and I like it because it's hands-on. It's one thing to use ChatGPT, for example. I like to build it. I don't like to use what other people have done. I like to do it myself.
Even if it's, just a simple thing, not this multi-billion parameter thing with trained for millions of dollars.
Yeah.
Oh,
So that's
really cool.
pretty much it.
Are you gonna have links to some of these resources or something?
Yes.
Where we can look at them later?
I have all of these pictures and videos, and all the source code is on a Google Drive, which I'm going to go now back to my old man Windows 7 machine and post that link in the chat. And then I'll also post it in the news group, on the RSSC news group.
All right.
Thank you. It's really about learning, about a
Thank you, Chris.
machine.
With that, let's go on to lunch and let's come back at 1, like 1:10-ish.
Yeah, or if we, well, one more business, what else do we need to talk about the business? You sent the file, right?
Yeah, I did.
Thanks.
Okay, so this is something this is another work-related video. This is something we presented out. This is like chain of thought, lane chain kind of stuff, but hooked to industrial automation software. So hopefully this.
Hi everyone, welcome to this demo of our industrial AI assistant. The context is I'm a wind farm operations manager. I've received an alert that my wind farm production has dropped unexpectedly, and I'm going to use the assistant to investigate why and what I can do about it. Here you see we're in our cloud visualization platform in Aviva Connect, and I'm going to open the assistant. I'm going to give it some context to my question. It looks like my wind farm output is lower than expected, but then I'm asking a very open question. Is there anything I should be aware of? It's gone away to search assets, events, and time series data to try and find reasons why my power might be down. One of the key pieces of information it's returned is that turbine GE07 is stopped due to a high temperature event. Next, I'm going to ask it to find me a dashboard for GE07 that's going to show me the utilization events. I open the dashboard and it confirms that the wind turbine has been stopped for the last few hours because of a high temperature event. A high temperature stop could have multiple causes, so next I'm going to ask it to find all the temperature tags for turbine GE07 for the last 12 hours. When it returns the answer, it's already done some analysis of the time series data, and I notice that one of the bearing temperatures has a maximum of 124 degrees C. That's already very high, and I have a clue why the turbine has stopped. I click on the trends and it opens the time series data on the left. As I scroll along, I see the temperatures increasing until the turbine stops, so we must have hit a high temperature limit on the turbine. Next, I want to find the maintenance manual for the turbine so I can make some diagnosis as to why these temperatures all went so high and what I can do about it. It finds me the manual straight away. However, I quickly see as I scroll through it's got more than 150 pages, so it's going to take me a while to search for the information I want. Instead of searching manually, I ask the assistant if the manual has any information about causes of high bearing temperature. It comes back with a detailed answer based on the information it found in the manual. Perhaps, for example, I've got a faulty lubricating oil temperature control valve. It also gives me some prescriptive actions which I can follow up. For example, check the lube oil levels, check the bearing installation, check the temperature control valve. Again, all based on the information that found within the maintenance manual. Next, I'm going to ask the assistant to find the 3D model for the turbine so that I can locate the details of the lubricating oil system. It locates the nacelle of the turbine. We click on that and it changes the context of the screen to the 3D model. We can then zoom in and locate some of the internal details of the turbine. Finally, I want to create a work order for the maintenance team to go to inspect the turbine. I've asked the assistant here to summarize the conversation we've had so that I can copy that text into the work order system. Thanks so much for watching this demo. We look forward to bringing you more updates soon.
Holy shit.
You worked on that?
Yeah, I did that. Yeah.
Wow.
So based on all the stuff that Alan was showing, like this is cool. I got to hook it to our data, and so we hook it to our data. I think I got another slide. So we created this orchestrator. We hook it to GPT 3.5 and 4, and we have a bunch of different modules in our software. So we're an industrial automation company. We have time series, we have documents, and so we created tools for each one of those. it interface through the orchestrator and it handed data back up to ChatGPT or GPT, not ChatGPT. And we use semantic indexing over on the right, so we have all these embeddings. So when you ask a related question, you find the right data, even though you don't have the right keywords. So you can't see this, but it's a pluggable. We can hook it to any of our apps. Then we've made the custom orchestrator for things like guardrails, hooking up the tools and all that business. One of the selling points when you're working with a big company, like they don't want their data going anywhere. So I have to reiterate over and over again, look, we take the data, just the data we need, we hand it to GPT, it throws it away, never trains, never anything. So I have to say that over and over because people assume that we're stealing the information, that kind of thing. So this is a much better model than training models locally. They're afraid of us training on their data. And then grounding. So the other big selling point was, yeah, we've used ChatGPT, it lies. It makes stuff up. The more you hand to it, the more you say, here's the data, give me the answer based on this data, the less it's hallucinating. So we're, like, it's not hallucinating, it might get things slightly wrong, but it's not making stuff up anymore. So this, again, based on this length chain of thought that we've been
RAG,
saying.
retrieval generation, and yeah, nice.
So that's it.
But even if it doesn't hallucinate, it gives you something pretty reasonable, just because you don't want it to make any mistakes. Is there like a margin of error that something might go terribly wrong based on the input?
Yeah. So this isn't productized. We're looking at disclaimers, one. So like, hey, use your head, think about it. And then second, we're adding citations. So here's all the questions we asked of the data, and here's all the data we returned. We're going to put that off to the side. So before you take action on it, just check it out.
Okay.
But it's finding the manual for you, the right manual. You can click through the manual, but we don't need that anymore. You can see it's the right manual or the wrong manual. So yeah, I mean, and again, largely this stuff is based on stuff in this club here.
Wow. I'm stunned. That is an amazing application. You didn't need a term for it. You didn't call it, instead of pair programming, pair engineering.
Yeah, I like it. I like it. Thanks.
Very cool. Thank you. Thank you. I've been wondering what you've been up to.
That's it.
Very cool. All right, you some more?
Yeah, this is kind of.
Okay.
All right, so next would be
Deleting things by mistake and.
Chris.
Oh,
Yes.
Where should I put this in front of what camera?
You can use mine.
Does that camera not?
Yeah, but that one is a longer.
This is just a broken robot work in progress. Okay. Just hold that over and this down.
They're all like that.
All right, so let's spin you.
There we go. Yeah, with everybody talking about quadrupeds, and I didn't have $100,000 to buy a spot. And, Dan said his was only a few $1,000s. Well, I figure I'm just going to build one, and I don't want to spend more than 10 or 20 bucks.
Yeah.
So I just made my own quadruped. It's just a square. It had 2 degrees of freedom legs, and I'm using cheap 99-cent SG90 servos. And of course, I love Arduino Nanos, and this one has an IMU. Not quite put together yet, but all the hardware is here. And my intention is to use the same software that I just demoed. And so now I have like a $15 quadruped that's going to learn autonomously how to walk. And that's it. So work in progress. So hopefully in the near future, you'll see this guy walking around. And that's it.
Is it like, is it spin the whole light part there as a walking? Is that how it walks?
Well, no, the mechanics, it's going to have 4 legs, 1 on each corner, and that's it.
Oh.
So it's just a square with 4 2-degree of freedom legs, and it's got an IMU, and I'm going to say, rise up and walk.
You're gonna have some pretty
Using
cool feet on
the
it.
code that I just showed you, it's going to learn how to walk and do its thing.
Yeah, that would be a great show and tell for next month.
Yeah. It's gonna, somewhere on here, so all the hardware is gonna get mounted on the top of this square here. Does it matter?
Yeah, inverted pendulum.
Well, I don't want the, as long as it doesn't get in the way of the legs.
Yeah.
It'll be tough
Even if I have to
when-
tether it for
when-
fun,
depending on
it'll
what
probably have a little
comes
battery
out,
pack on the
I
top.
mean.
And
kind
of
of
course,
for
it's
stability and
cheap
you
3D
might want
printed
it.
everything, so this is all 3D printed parts and super glued. That's it.
Nice. I can't wait to see you do the
Hang on a minute.
It'll figure that out. It's got an IMU.
Who's next?
Physically, it's gonna take like larger steps and then.
I have this, this is ready now.
Oh, this is ready?
Yeah, I just,
Alan.
it's like, yeah, I had to make mistakes here, but now it's should be good.
Okay, did you?
Let me boot up first and see. Make sure it's working here. I'll boot up the emulator.
Can you share the image?
Yeah. All right, we're getting the emulator working here. So that's it. Oh. So here's the key thing. So the contest is using an Apple II emulator and RobotWar, Serious Warner from New Software 1981. So let's see if we.
This takes me back.
Yeah, I want to make sure that the robots are here even. Oh, you know what? Maybe it isn't that simple. I have to copy the source code as well because I think it registers. Yeah, the old way I mentioned it might be the only way to do it because even though I copied the files, they're not showing up here in this list.
Okay, you want to?
Yeah, well, and then the people participating, can you send me your S file, the source of your robot? You sent me your whole disk.
The whole disk, yeah.
Yeah, I could see.
So yours would be S colon, same name, yeah, same name. Okay. All right, never mind. Oh, sorry about that.
Sorry.
This is yeah, this is a kind of a learning experience, archaeological source.
All right, next for sure.
You're last.
Okay, all right, I can take as long as I need, but no worries. You know me, I love to talk.
Yeah. All good.
All right, let me go ahead and. All right, so normally I don't like chatting about stuff that I read on the internet, but an ongoing trend that I've seen over time is just how many humanoid robots are either currently available or will shortly, or they're threatening to make available as a product. And of course, any discussion of humanoid starts with the ASIMO. The single project that got me excited about robotics when I was a kid, not to age myself, waiting for years to turn into a project, and then they mothballed it, never to be seen again. Atlas, Boston Dynamics, they have a commercially available quadruped, but everyone keeps waiting for a tipping point where they offer Atlas as a product. Ever more exciting videos showing its capabilities. There's never been any promise, but I always have my fingers crossed that just around the corner they'll have something available for sale. Another big name that came out of nowhere, Tesla. Their Tesla bot, as much as I like to bag on Tesla for failed promises and timelines, the progress that they have made in a Tesla humanoid robot is impressive. To go from, hey, let's drop 10 or however money bags wants to throw at it, to having something that's capable of walking and teleoperation in 2 years is nothing short of impressive. So I have to give them credit for that. Notice there's a lot of tabs. Things have changed over the past couple of years. I'll include Ricci from Fallen Robotics. Maybe it's mobile, maybe it's not. It is open source. I don't know if they're selling it, but it's been around for a couple of years now. Amica, non-mobile, super impressive platform. When we were doing our short movie, I reached out to them to see how much it would cost to rent the Amica platform for a weekend of filming. They said, you know what, for you guys, 120,000. And we're like, you know what, that's great. Good luck. We went with I mentioned earlier, Digit, Agility Robotics. These guys are serious about it. Their 50,000 square foot manufacturing facility has more than broken ground. It's either opening up for production at the end of this year or beginning of next. These guys are going all in with an actual product. I think I've seen news articles talking about Amazon being a main customer. I don't remember seeing pricing on it. Back in my head suggesting 75, 90,000 in that range. I don't remember for sure. But this is something that is going to be available to buy in the near future. Unitree and the rest of these, except for the Toyota bot, they're all variants of large BLDC low gear ratio motors, and they all have about the same framework. These guys are saying that their Unitree H1 will be available. Why is everyone so violent? The robots are going to watch these video clips and they're like, you know what? We were considering sparing you as a species, but gosh darn it, you guys are so mean. So Unitree is claiming that this will be a product that will be available soon. And I can't remember if these were in the 60 or 90,000 range, but we'll see. If it's any like their go-to, it'll cost twice as much when you add the import duties and shipping and et cetera, but we'll keep an eye on.
And the t-shirt.
And the t-shirt. Apptronic has their Apollo. Some of their videos are actual videos and others are renderings. They use the Omniverse platform for physics-based simulation. And if you want to figure out which is which, just keep an eye out for the cables. So if you don't see, cables, power cables, that one was live. Power cables, this one was live. Some other clips will be simulation, but the simulation is so gosh darn good looking, it's hard to tell the difference. So these guys are claiming to have a product soon. Sanctuary AI Phoenix, another variant. They're claiming to have a humanoid that's going to be available for purchase soon. Xiaomi threw their hat in the ring earlier this year. Cyber One, they have hardware. They have video clips during their keynote speeches of their robot handing their CEO a flower. There must be some cultural meaning in that. So they're claiming to have a product soon. Eve for 1X. Another humanoid. I don't remember seeing video of it in motion, but they're claiming to have a product soon. Figure AI, the Figure One. It looks very Tesla, but they're getting closer to having a platform, and they're promising to have a product at some point. Fourier Intelligence, the GR1. This one looks slick. Again, I can't remember. I think they started publishing live video of their progress, but very slick platform. So you've got the huge low gear ratio BLDCs in the hip. This is supposed to be a product they'll be releasing pretty soon. And Toyota is more in the Honda category. They haven't talked about productizing it, but they've kind of thrown their hat in the ring with this really cute 4-foot tall humanoid that's teleoperated. And these were all the ones that I could find in the 10 minutes after we got back from break.
Do you have web access?
Do I,
Yeah, can you go and then pull up Kind Robotics?
oh, did I miss one? Yeah, for sure.
Yeah, well, that's from the HBRC club. It's not just the HBRC, but Christoph is a member of that club.
Kinderlab?
No, no. Kind Robotics. Ben, I'm having trouble compiling yours.
There you go, that's it.
There you go, kindhumanoid.com.
Yeah, that's Christoph's picture.
Oh, the orange plastic bot, right?
Yes.
Because, yeah, here, let's see.
So he uses a completely different, he doesn't use quasi-direct drives.
Wow, this is.
That's in his garage.
It just does nothing. Have you noticed that behavior where it's his?
So he has, he's just using VLDC motors, but he has a very unique design. So you can see the motor spinning. He has got these super strong cables. They're, I forget the material they're made from, but very strong, stronger than it needs to be. And he runs those throughout the whole robot. So his robot's a bit different because it's designed, unlike the other robots, it's designed to mimic, to biomimic every movement of a human being.
Wow.
Christoph's a very smart guy. So a lot of people say it's overcomplicated, but I like his approach. Although building it is a
Yeah, that's it.
and he's got it obviously hooked into ChatGPT, so he talks to it and it does stuff.
Well, anyone who says it's overcomplicated, I'd like to see their humanoid.
Well, you know, didn't I just say that on that's on the HBRC list, I think I just said that. Yeah, it's like, building humanoids is easy now, or simple or something. And
According to some.
according to some people, and I said, well, okay, well, I rebuilt mine 6 or 7 times. Show me the video of yours walking. That's all. There's the can do. He has a video of it walking, which is a relatively new, and he has received, I think, well over $1 million in funding.
Oh, wow.
And he's currently hiring.
Yeah, somehow.
So if you want to go on his website, if you think you have something to offer, contact Christoph. And
What's the trajectory? Is he trying to monetize this?
Free somewhere.
Oh yeah, he's going commercial with this.
Oh.
This is not a toy.
No. So,
obviously it's a very,
yeah,
it's a
I
toy,
met
but it's
Christoph
a
at
very,
the show,
very
and,
expensive, complicated toy.
And he was hiring. I invited him to give a talk to us at some point in the future.
Christoph will be happy to do it. You should just contact him.
I mean, I talked to him in person, but I don't know. Well, he was like, you know, he's formed a company, and he's got funding.
Yeah.
It's like venture capital.
I want to be him when I grow up.
Yeah, I mean, he likes, you know, during COVID, he kind of, you know, was secluded, and he put all this effort into the design and manufacturing of this prototype.
And all this is in his garage.
Yeah.
He converted his garage to a workshop. He's got some pretty cool toys.
Wow.
Yeah, so he's hiring, and I said, yeah, you're welcome to advertise for hiring at our club.
Yeah. Well, actually, I volunteered my work. So one of the problems he's having, and I don't know if he's solved it, is he has a lot of controller boards in those motors, and he's got a CAN bus that he's using to communicate to all of the processor boards.
Yeah.
And CAN is, and it's a slow CAN bus, it's not CAN FD. So he's having kind of a data throughput issue. And I said, well, you know, you can use the differential transmit receiver of the CAN bus and throw away, as long as you can put a serial, one of those USART serial lines on the peripheral lines where the CAN bus is, you can run a sort of a pseudo EtherCAT, but instead of using the Ethernet protocol, you use something like that, where you send a time-based data packet around, and each motor fills in its own data within the stream, and it always is circulating. That's the way EtherCAT works. So for those that look at EtherCAT, the problem with EtherCAT is that every board needs an EtherCAT receiver on it, and it gets pricey, so people don't really want to use it for a lot of servos. But you can do the same thing with a serial
line, I think those serial ports on those ST micros will run up to 5 megabits or faster, maybe up to 8. So if you have a differential bus for immunity from noise, you can create your own circular link all the way around and just, timestamp your data and make it like EtherCAT, and you can get tremendous throughput without a horrible CAN bus architecture and all the stuff that Bosch went through to make CAN work, 40 years ago. But anyway, that's what I proposed to Christoph. We talked about it a bit, but Chris asked me why I'm not working smart.
Was the link on HB Robotics?
HBRC?
Was it was it the Sanctuary? Someone did a 3D scan of the bot that you could fly around. I'm trying to remember where I saw it. I don't remember where I saw it at. It was they offered to scan the robot and then you could fly around. It was someone that has an online tool.
No, you mean you fly around?
It's a 3D.
3D visualizer.
Yeah. Do you remember where?
No, I don't.
Shoot. All right, I'll have to keep an eye out for it. So I was thinking about opening up a section of our website just to half-heartedly keep track. There's so many of them. If even half of them become products, on the hardware side, we reached a tipping point where building humanoid robots is less impossible than it was before.
Well, it's funny. I went to Sacramento and I went to the car museum. There's a really, if you like old cars, if you like history cars, in Sacramento they have this great car museum. And my girlfriend said, we were up there, she says, you want to go to the car museum? I thought they'd have like 30 or 40 cars, and they had hundreds of cars there. And you look back at the turn of the 20th century, from the 1905 time frame. Well, they had some electric cars, and then they had some single cylinder cars and stuff like that, steam cars, and everybody. There were a lot of car companies that all went out of business, not because they didn't have great products, but they didn't know how to productize it, and they didn't know how to innovate. They were inventors, not innovators. And in any industry, it's not the first guy out that wins, not the inventor, it's the innovator. It's the person who takes the failed product and goes, this failed because of this, this, and this. I bought it pennies on the dollar, I know what the problem is, and they innovate the product and get all that IP. So the story is that I still think that the jury is out on which companies are going to make it, and whether or not. Obviously, Tesla's fail because there's so many bucks for them. But some of these other ones aren't. I think Boston Dynamics has it right saying that we're not putting the Atlas out because you can't. Boston Dynamics was bought by Google. They couldn't figure out how to monetize it. They chucked it, right? And so now the only thing that's making money is the Spot. And so they've productized the Spot, and they're making a ton of money on the Spot. But they realized that the Atlas is just.
Do they just use it for R&D or just?
It's R&D and
demo.
And then just figure out how to make it smaller, cheaper, better. I mean, they use hydraulics in it, and so it's tough to build a robot that uses hydraulics that's safe. Right. I mean, you've got how many thousands of pounds of pressure in a little pin needle thing. It's like a laser cutting tool, right? And think about it.
Blows, it could cut through flesh and metal.
That's right. Yeah. So it's like a water jet, right?
Ooh.
It can cut through a lot of this. So hydraulics is I don't know. Originally I wanted to use hydraulics, and then I have a tractor that has a pump the size of this cup, and I push this giant 2,000-pound thing. I go, how does that little pump do that? There's a lot of pressure.
Yeah, water is not compressible. Liquid is not compressed.
So it's really dangerous hydraulics, right? So how do you make a robot hydraulic? But yet the good stuff of hydraulics is you can lift it.
You can lift stuff.
Yeah.
You can control aerodynamic surfaces with a tiny amount of force. All right, we're ready for finally. I had to do some gymnastics to get those files to get onto the same disk here, and actually,
Is that a disk? Yeah, that's a disk image.
What's a disk?
Yeah, well, it's like this,
You mean like
right?
the save
My
icon?
first disk was 8 inches, we had 8-inch floppies when I was a kid. Yeah, I had 8 too.
Yeah,
Oh, how cute, you 3D printed the save icon.
Exactly. All right, so, I may turn off the sound. Yeah.
Oh, here, let's do that.
Or can you, I can turn off the whole sound, but it's nice if it's really low.
Okay.
But how do you, I can't seem to control the volume
There you go.
from my computer of what's coming out. You can control it though, right?
Yeah, just so it doesn't over,
It's like, I put it down to one thing and it's still, it's like, through Zoom, does Zoom have its own,
I'm not sure.
or well, let's see what it comes out. All right, I'm gonna run the scheduled match. This is, unfortunately, this is like, everything just happens. There we go.
So who's who?
Okay, so Jim, Ben, and,
It's supposed to be Robo Nerd.
Robo Nerd, yeah. It's Robo Nerd.
There's some characters there, I think.
I had to rename it,
Okay.
otherwise it wouldn't show up. So, okay, so let's see. All right, here we go. Here it is. And you can turn up the noise a little bit.
Can you tell us what's the goal?
All right. It's a or you want me to give some ahead of time? Robots are in a simulator, and the robots are all tracked. They have their own they have their own like tracks. They can go left and right, up and down. So your goal is to seek out other robots. They have a radar turret. Yeah, and they have a radar turret that goes down, and then and when you fly, you get damage.
What's the percentage damage?
Percentage is the damage. So I'm this guy, Robo okay, and then where's Ben?
Why is that one going to
You're going up here.
top left?
Yeah, I'm sorry, these icons aren't very easy. Like this one.
I'm gonna top left.
You're nicely stable. Like, shoot. It's really hard to program. It's assembly language.
Oh, so you write assembly language.
It's not, it's like,
Your robot against.
yeah, so there's 5 robots interpreted. Yeah, it's like a pseudo assembly. And
Oh, it looks like Ben did it. Now that
yeah, so I threw some that are actually rounded from some guy who did it years ago. But I kind of this on all of your discs.
You played.
Well, over the past few days, I really well, I was the one that's yeah, but that's round 1. Now there's round 2 and 3.
Is the object, you touch the robot, you get them, or what?
They crash.
So so I can explain the yeah, you shoot out of the cannon. You can aim the cannon in any direction, the compass direction, and you can scan in any direction. And so you scan, use the radar, and if the radar comes back negative, that means that there's somebody there. Then you shoot. You can aim in that direction as well. So there's 2 things: radar and aim of the gun. So you'll see that this tiny little line there is where he's aiming.
Do you have 360 degrees?
You have 360 degrees. You have more resolution than what's
Okay,
on the
it's not
screen.
just-
Yeah.
Four.
So, oh good, it's not starting. Oh, this thing is so many automatic. So yeah, so you have to aim for it, you send a radar, and then you move your turret into the radar and fire. Well, you have to, you can just shoot randomly, but if you shoot radar, you'll get back a pulse, you'll send out a pulse. Well, the radar returns, yeah, well, not exactly, just, yeah, so that part's automatic,
Individual robots.
You have to write code for each of these, and each of these the scope gets compiled or assembled, and then running all that in our model, actually one instruction of it. So I'm gonna die. Who's left?
Left with, I think it's over there.
The one at home? Right there. Oh, you need a robot. Is this, but this is the one that needs, well, let's let it, I want to let it record the score. So I guess I could enter. No, that's like, you want it.
How do you know that the person did that?
Well, the only thing you have is radar. Radar, and
then execute a
then if the radar comes back
running that code.
negative, then that means there's somebody there. If it's positive, it means there's a wall or something. So then you can shoot at that. Then you take the angle, the aim, and you shoot at that.
By then you're dead.
Oh, really?
Because you're executing.
Is this gonna be the?
This would be the third time.
I hope this is the scheduled thing and not just the.
Scanning.
I have to do one more. I'll show you the source code. It's very simple to So my strategy was I go from corner to corner. I have to all this code to figure out how to move from a corner to a corner of the with a little sort of almost to the corner, and then only take my in down to the larger space. So what it's saying because those guys got in the corner. So I don't know. I just had a strategy that. And if I said, hey, I need another corner, the idea was that I would scan the angle from the corner to the but yeah, it's very hard to debug and work out. That's what I sit as long as you corner outside the corner. My strategy was go to a corner and fire it away from the corner. Exactly. I did 190, but it was 100. It's like, yeah, I should have during the middle. Yeah. Now some people have a strategy of alternating at 180 degrees, so would process. You go in the exact middle of the corners. Oh, aim at the corners? That's if people go to the corners. And here's my strategy. This is bad for me because I didn't think, I was hoping people would go to the far corner. So the only time I can get them is if I get well, after a while, I decide to move to another corner. Oh, there it goes. No, you don't have any idea. Ooh, crap. No, the only way you can go is with a radar. So you have to, like, say, you have to give the radar an angle so many degrees and get a pulse. You have to. But I mean, that's the resolution. I understand that. Right, but I don't, I decided I'm only scanning away from the corner. Right, so what I'm saying is that why do you not know this guy? Anything from 90 degrees down to 150 degrees, there's someone there. Well, you can only scan 1 degree at a time, one at a time. But the guy in the corner, if you get anywhere between 90 and 100, well, they're there. So one of the somebody's not arguing. Yeah, no, that's footprint. So what are you doing over there? Well, that was my strategy. I make like corners and from there, but it's very much counter to you what your it doesn't go all the way up. It goes like is it because the other guy's right next to you? I'm not following you. I'm not following you. Well, that's what I'm saying. If I have somebody on the same part, it goes up like 50 degrees. And then it comes back and he's 90 degrees away. You can't tell when you can't version of this game that plays on modern Windows. Oh, there is one. We wanted that for nostalgia. Oh, come on, fire, come on. Now I'm in a good position. I can take them out if I don't die on them. So if the robot is on the same horizontal plane, you aim your radar behind it. You don't feel it. Yeah, I see that. And if I aim at 91 degrees, yeah, there's a range. There's a range, right? There's an angle. That's true. That's oh. Get out of the way, Grandpa. Oh, yeah. All right, then. Nice. Yeah, I guess I'm not sure where you're confused. It's just, yeah, if you, your radar will detect, if you aim it within the angle that the guy, if you drew a line there and it intersects the robot, you're going to get a negative pulse on the radar. Then you just fire at that same angle and you'll hopefully get a hit.
But I guess what I'm saying is that the further away the robot is, the tighter the angle.
That's true, yeah. But you have to program it. Yeah, that's true. I like go by 11 degrees per move or something because I want to scan enough. Otherwise, I won't get enough.
What's the purpose of moving around? I mean, because you can fire at a distance. Is it to be evasive?
Evasive, yeah, mainly. I mean, some of these robots are just like a mover. That's his strategy. Keep moving around. Because if somebody gets a lock on you, they'll pound you and you'll die. My strategy is if I get hit, I move. Yeah. That wasn't the part of the tournament. That's all. That was the third
Well, I was talking about something called red code. It's very small, memory. Trying to relocate, destroy the program. And the end result was genetic algorithm involved with the until somebody found the opposite. Basically, red code
my robot's supposed to go to the you get random randomly placed at the beginning. Every time you go into the familiar location. I have a more modern version, and I'm not going to talk to you guys about it on the PC, but we decided not to be much more modern. It's in color, and it's much better than this. The same idea.
I remember reading about this game in a magazine and being blown away.
Yeah.
I never was able to purchase it, but
Take out, what is it? Ralph. What I do is I come on the board and I try to find the closest corner, took some code, and then I go to that corner. But, or maybe I've just been unlucky and got placed close to that one corner every time. No, I was going to the closest corner. You get randomly placed. And eventually I decide I'm switching corners after so many. I have a timer. Either if I get hit, I will move. If I get a timer goes off, then I move as well. I'm glad I put the timer in, because otherwise. But I shouldn't be always going to the left. I don't know. That's so random. Okay, fire. Fire. I just don't figure out what it is. So this is a, like you said, since I'm can't be 11 degrees, it's hard to. But since it's 11 when it goes around, it's gonna do yes. Yeah, that's even more. But I think if the further away you are, you're gonna miss the person. For some reason, when I get to the corner, my corner doesn't go down. Well, right now, that's it's only scanning like 10 parts. Come on, fire! Yeah, it's supposed to scan all the way up. I found way up there. Oh, see, it doesn't, it's not, it's supposed to go all the way up to the scanner and then come all the way down. Yeah. We fucking started a square, but it's only stuck at, like, you can only see like 17 back down. I found mine to be behaving weird, but I found that, like, I kept another accumulator, like another variable, and when I go above 360, then I hook that into the radar, and the radar takes anything above 360 back to 360 automatically. So I kind of use that to my advantage, so I can only go once, so I can go from, 135 degrees all the way to 45 degrees and backwards. Always the hardest part is going through the 0 to 3. When you have to transition any trigonometry, when you go through 0, it's like you're switching from positive to negative. You're going up to 360, and now you're going to some other number, and then you want to go backwards through that. You don't do it that way. Yeah, 200 degrees. Very certain. Just I'm talking about the fact that in your algorithm, you always in a given number. You're automatically 0. No, I'm talking about degrees here. Like, whenever you hit the north, when you want to scan something through north, you have to deal with the 360 degrees transitioning to 0 and 0 when you go to plus, that's what I'm saying. You're right. No, I'm not. I'm using I
we
usually
gotta
use
head
it.
out.
Yeah. Thanks, guys.
Thank you very much.
My first time I've been at an actual live meeting.
Live
versus
This
cool.
I'm glad that we're able to-
Where were the
Yeah.
scores? Come on down in this area.
I'll have to watch the video. What are we missing by leaving here?
Nope, that's it, I think.
Pretty much.
Well, I think we lost the scores, but, did I
So
win twice?
Jim
Oh, guys.
won twice and Ben won once out of 3.
Because it's supposed to, it has scores, but I think because I waited in between those, it lost the scores.
So did you should go.
So, but.
So you probably.
So you won, Jim.
Thank you.
All right.
2 a.m. it was worth it. I eat pie. Did I explain all that well enough? Yeah, so, those guys right here, I brought Chris, but he's going backwards. With Dan. So yeah, well, let me show the,
Oh, yeah.
we wanna briefly here, for those people, since we just spent a lot of time with that, let me get out of this. The software is really not, it's kind of not friendly, it's gooey. You have to, just like they don't have exits everywhere that you should have exits. And they have these automatic things where it goes into the game without you wanting to, like it's an arcade game that needs to get more quarters. So here, let's, well, I'll load, or we called yours Ben 3, right? So yours is pretty.
Mine's is simple. It finds the top left corner and then it's supposed to scan and start
Good seeing you
shooting.
again.
Hi, good to see you too. Hi, everybody.
Right, so that.
So mine literally just goes to the top left corner and starts shooting from there, but it was supposed to scan the entire field, but it only going to 17 or something. Or I don't know how
If
many
aim is
degrees.
greater than 80 to I, you have to, what's interesting is some of these variables have a different meaning when you read from them than when you write, because they're using them for both. Like shot, if you say something to shot, that's an angle to shoot, or an angle to shoot at, or is that, that's the distance. Something to aim, aims the gun, then you take the value you got back from the radar, which is the distance, and you say that to shot, and that will explode the bomb at that gun. But then if you say shot to variable, you get the cooldown for the gun time, or you get a number that goes down to 0 when the gun is ready to fire again. So I can use that. But yeah, then where's your shooting? Oh, there it is. Yeah, see, 0 minus radar to shot. So radar returns you the distance, and then your 0 minus the radar is the distance to shoot. And aim is where the gun is, and radar is.
The angle of the radar where it's pointing.
Yeah, you have to. Where's your? I don't see your something to radar, because that controls the radar.
Aim to radar.
Where's it?
Aim to radar.
Aim to radar.
And
Yeah, that's
two
it.
lights
Yeah.
up.
So that's the standard. This is like the standard approach. I'm not sure why it's not working, but and then this is yours. He also likes to move to the top.
So what this is supposed to do, it goes to the top and then it goes to the left. And while it's going along the top, it aims down and shoots.
That's
When
like
it hits
a
the left, it does what Ben's does, and it sweeps. And then when it's done with one sweep, if it finds somebody, it'll keep shooting as long as it's.
as long as they're in the gut range.
And then if it finishes the sweep, it goes to the right-hand corner, sweeps to the left. So it.
Ah.
but it's
Well, that's
not-
similar
it's
to,
not doing that at all.
you and I did similar strategy. Because I'm like going to a corner and then trying to sweep down away from the corner, right?
So somehow when I was rushing to leave, I got the wrong version or something.
Well, so you probably would have beat me.
I don't think so.
You guys want to rematch next
No.
month? I ran out of time this month, but,
Oh, yeah, I think this
would you be
I
down
think this
for a
whole
rematch
thing
like
is
that?
not, Well, I already have a robot, so I mean, I'll just reuse it.
The editor and.
It's just so kind of cumbersome. to
And
work
the
with this
language,
thing.
they're torture.
It's torture. I felt like my whole
Goodness.
software career was like, no good.
When I was in the editor,
What?
I would hit, everything below. would
Everything
disappear.
deleted. Yes. Except,
So
okay.
it was fun because you had like the retro feel of it.
Here's
But
mine.
if we're gonna do another contest, I'd do a modern, pick a
Yeah,
modern version.
And here's my
That's
behemoth. I ran out of space. It stops at 250 codes after you assemble. And mine, I tried to put in that wall evade thing that the Ralph guy did, and it went over the 255, so I took that out. But this is under, mine is like 215 out of the 255 available.
A good example is you
This is how long.
move by setting your X and Y speed, you don't set the angle. Where you're shooting, you set the angle. So you're like, okay, I wanna aim the way I'm traveling.
Yeah, that's a thing.
So you like take the sine and cosine of your move angle to get the angle to aim. And there's no sine and cosine. So, and if you wanted to write your own, you could probably figure it out, but it's taking that many lines of code, and each line of code takes processor time. You can't do that.
I was sitting there doing nothing, and these other robots are moving around, because I was trying to do something just slightly complex, like, flying the, so I had to try
And
to
it's round
optimize.
robin opcode, right?
Yeah,
Yeah. So you get one line of code, he gets one line of code. So if you try to like write your own sine function, no, you can't.
No, well, you can't do that, but, well, just to give you a flavor, when you assemble one of these robots, this is kind of what it looks like. You see assemble from source code, and then like the assemble gem, for instance. These are the commands. Oh, I can slow it down. The commands here, like, it's converting the language you just saw into this even lower level, basically if statements and go-tos and setting values and evaluations, and that's about it. It's very simple.
255.
And this goes up to 255. I almost, I got too much. Now, there was no problem with the text limit. The text limit, I was only like 1K or 1.5K out of 10K, but we run out of opcodes quite quickly. Wow. But so, yeah, what you have to end up doing, I mean, this is an interesting exercise, though, as a programmer, to like really try to optimize the way you think about an operation and do it in assembly, because you have to have all this stuff in your head like a normal Arduino or an advanced Arduino robot. Like, you've got to deal with obstacles and enemies and movement, and I find myself having to do a little bit of a control loop, in fact, because it's like when I want to move to an XY location, even they had it in their example code, they would do, your position minus the X, times a factor, like a K, a constant, and then set your velocity to that. So it's a little, and I had to adjust that number, like to 3, 2, or it would overshoot and oscillate. It's just like, this is how kids, or if I were smart enough to, like, when I was a kid, to actually do a lot of work in this, I would have learned, or if I had a teacher or something, I could have learned the basics of a control loop, right? Because this is like right there where it says go HV. H is where I am, minus X is or H is where I want to go, X is where I am, times a factor to speed. So as you get closer, it drops down. It's just like a little tiny control loop of sorts.
My second version, the one that I couldn't get to work because it just kept crashing into the walls, even though I had a wall avoidance function.
Yeah.
That one was fast. I mean,
Yeah.
I was giving it a multiplier of like 100.
Oh, right.
So it moved fast, but it wouldn't stop at the walls.
That's the thing, like, mine, I didn't put in any of the evade wall, and I thought, well, my algorithm means I won't hit it, because I only move to the corners, and I use the extra time to compute where to go, and then I adjusted that multiplier so I don't overshoot. So there's some downside to that, but at least I don't have to put in a big wall, because I hate hitting the wall and you get damage every time you hit the wall. So it's, anyway, yeah, I wouldn't redo it well, unless people, yeah.
Okay, yeah, just curious,
But I think the idea is good though, like having simulator contests, that's fine, it's just that particular one.
This was a one for nostalgia.
Yeah,
and
exactly.
that sort of thing. Oh, we're already at, that took, well, we got several of our show and tells.
Yeah.
Are there,
All the show and tell
I was
are
gonna
done.
do mine next, which is you guys have to go?
yeah,
Or is mine next, or? That's fine. I'm just gonna do a recap of the Maker Faire and stuff on the order.
alright, so, Ryan, I wanna ask, just because, you've been a little cagey about something I working on. So, your presentation was recorded, is it okay if that's
it's good,
public?
yeah,
Okay.
yeah.
Okay.
That's why I waited, it's already public, we went on our conference later, yeah, it's
Cause
good.
that was that's you, right?
The guy talking?
No, the AI portion of the.
Oh, yeah, that's.
That is,
All right, I'll watch it later. I couldn't.
I'm gonna show that to my bosses, none of it directly
I
applies,
got
but
the
to.
video itself, I could send you or something. You wanna show that
Actually,
one?
yeah, that would be awesome, just to give them
It's
an
really
idea of what a successful integration looks like.
Yeah.
Cause, we're starting down that path where I'm trying to, I got in front of them what's out there, and now we're just looking for possible use cases where it makes sense to marry generative AI, directed cognition, computers as well. So,
Like in the afternoon, evening with pizza.
Yeah, I'll send you like a drive link or something like that. so
Okay,
it's
oh,
not-
that would be awesome, yeah. Thank you.
Alright, usually.
Yeah, I'm stretched, but I like to put a little time into the vintage world occasionally. It's like a little, because it's so much fun. But see,